everyone. Thanks for coming to New York for this event. We're very excited to have you here. So we're a bit late. First of all, logistics. Has everyone been able to sleep correctly? There was a few hiccups for the check-in, myself included. So, but I hope it's okay. Probably you noticed the breakfast is much better here. So just keep the breakfast over there and come here. 8:30, it's much better, and it's a nice place, right? So yeah, so I'm Julien Girard. I coordinate this data challenge under the guidance of Margaret. And so I'm going to let Maggie say a few words and of wisdom. And then maybe we can present ourselves a bit quickly, and then we move to the presentations.
I don't have slides, so I'm just going to chat with you for a minute. Thanks, first of all, for getting yourselves here, for coming and getting yourselves here. Please don't, all of us are new to at least some aspect of what we're going to go over today, so don't hold back as far as having questions about how these things work, and please, if you can, take advantage of the fact that phones have silencers on them, and take advantage of the fact that we're all here together just for this brief time, and it's a good opportunity to get to know, what each other is interested in working on, for the possibility of forming teams and actually joining the Real Data Challenge. So far, we do have several people signed up for the data challenge, so I think it's going to be a fun competition, and regardless of where you feel you're at, if you have the time to participate in the data challenge this fall, we're going to support as much as we can going through. So I think it'll be a really good experience, and we're excited about the data set too. It's going to be tough. It's going to be really interesting to work with. WFIRST, if you, again, as questions arise while I'm talking right now, please feel free to ask, but how many people are intimately familiar with the WFIRST mission and the coronagraph? Okay, so we have a few people who are very familiar. How many people are not as familiar with the mission and the coronagraph? Okay, so the WFIRST mission is Hubble, is the size of the Hubble, a 2.4 meter telescope that was gifted to NASA by the National Reconnaissance Office, yes, gifted to NASA, and became then the new WFIRST mission, which was originally in the last decadal review ranked as high priority for a smaller class mission, but now it's going to be a flagship mission that has the opportunity to actually do exoplanet imaging. So the coronagraph is an add-on to the original vision of WFIRST. Doing exoplanet imaging was not originally part of this mission, but with the new, bigger telescope, that's actually possible to do. So this will be the first camera to fly in space that will be operating with wavefront control in space and doing coronagraphy on the nearest stars to detect planets around them directly and take images of planetary systems. The top targets that we will be pointing at are systems that have planets which are known already thanks to radial velocity detection. But there is room in there for new discovery within those same systems, that for planets that fall below the detection limits for radial velocity, and for other targets that we could search that aren't known to have planets, but that could show up in the images. So the coronagraph is a technology demonstration. It's not considered to be, I don't know how you would say that, part of the main mission. I mean, it is part of the main mission, but it's
not a science instrument.
It's not a science instrument that is it's a technology demonstration. It doesn't have science requirements. So in order to be a success, a successful technology demonstration has objectives that relate to very specific observations that are already all planned out. And then beyond that, once we get through the tech demo phase of the instrument and have established that the coronagraph is performing according to the performance requirements. We have engineering performance requirements, not science requirements. But once we get through the first year and a half of tech demo phase, there's possibility for continued science observations beyond that potentially. So that's on the table. But for the immediate purpose of the coronagraph is just to demonstrate the technology so that future missions can build on that. And that'll come up more, I think, just as we talk about things over the next 2 days. But does anybody have any burning questions about the mission?
How many hours committed for coronagraph?
We have 90 days of time for the tech demo phase to be used up within the first year and a half of mission. There is also the coronagraph and telescope, I guess, are baseline to be starshade ready. So there is a possibility that after the next decadal review, if they recommend it and rank it highly, we have submitted a proposal, a study on a rendezvous mission, a starshade rendezvous mission. So if that is ranked highly and funded as its own probe scale mission, a starshade could fly later in the 20s and rendezvous at L2 with WFIRST and do starshade imaging. So this data set includes starshade images as well for later epochs. So you'll have coronagraph imaging. The epochs are two epochs in what I call a fast follow-up. So for the purpose of discriminating background sources by proper motion companions. So 2 images that are spaced as closely in time as possible that the star would have moved at least 1 PSF relative to the background just from its own proper motion. So there should be minimal orbital motion of planets, but they should be tracking the star, and you can rule out background sources from just those. Then the idea is that we want to design our observation program to be like that, so that if the whole mission fails and everything breaks, at least we would have, 2 fairly quick observations that would have been made to discriminate what isn't associated with the star physically. And then you'll have later epochs that will show orbital motion, and then you'll have starshade epochs, which starshade is a much more powerful setup, you will find. So we won't be unveiling that data until a little bit later in the tutorial, just because it's like, ta-da, here's everything. And and also there's no guarantee that there will be a starshade, but we hope. I don't know if there's anything else.
No, I mean, I think we can move on. Just maybe adding that you could, in many ways, the WFIRST mission is not necessarily the ideal telescope to do high contrast imaging and coronagraphy, because it's, it has this huge central obscuration and spiders. So it's not the best optical design to actually make a coronagraph. On the other hand, it's a good size mission, it's a good size mirror, so you have a decent inner working angle and, well, capability to separate the planet from a star in a reasonable distance. And it's the best shot we have to fly in the mid-2020s, something that advanced. And so that's pretty motivating, and that's why we are kind of trying to get the community involved right now, especially young people, to know about this new kind of data, new kind of contrast. And this is fundamental because they will, Le Voir and Habex, if they exist one day, it's going to be thanks to this kind of tech demo.
Yeah.
You don't want to, put all your eggs in a basket and make a huge 15-meter telescope, for example, a bit like James Webb, but even bigger. with wavefront control, and you haven't done it in space. So that's one of the, so that's why it's called the tech demo, and that's why I guess for the high contrast community, it's almost as important as if it were a science instrument.
Yeah, and you'll see too the performance here. I mean, what we're gaining access to is old planetary systems like our own that are shining in reflected starlight, not the wider planetary systems that are very young and radiating in the infrared because they're giant planets that are emitting a ton of infrared light. That's what GPI is doing from the ground. So in space, if you want to see planets, especially eventually Earth-sized planets, that are old, like our own mature, like our own solar system, you have to go to space, and that's why we have to get this technology up there and working. I'm going to turn it over to you guys, but welcome. And this is our fantastic team. I hope you get to cross paths with all these people at some point.
Yeah, thanks. Thank you, Maggie. So just before we go to the presentations, I just want to say that so on the website I added the agenda here. So if you're lost, it's also on the Slack channel. You just click here and you get the agenda for today and tomorrow. We are not necessarily going to stick exactly to this agenda. It's kind of a guideline. We already started a bit later. We have maybe remote participants. Right now we have one. But the remote connection is only possible in this room, and we have this room until 2 p.m. basically, and then we move to the Flatiron. So it's a little bit a complex setup, but it seems that it's okay. Another thing I wanted to say, okay, yeah, so maybe we can just like quickly, let's say 30 seconds per person, present ourselves. And what we do. So I work at Space Telescope. I work mostly on James Webb, and on science side, I'm interested in exoplanets, in direct imaging, brown dwarfs, and protoplanetary disks. Neil.
Hi, I'm Neil Zimmerman. I work at NASA Goddard. I'm on the WFIRST project science team, so I'm involved in a lot of the data simulations and processing approaches, and also on the side working on different technologies for future missions that will come after WFIRST, hopefully carry on the same path.
I'm Maggie, and I'm the PI of the science investigation team for the coronagraphic instrument on WFIRST. And I live in Wisconsin, in Madison. I'm actually a freelance scientist, so I work with the SETI Institute, write all my own grants, fund myself and my teams.
Hi, I'm Sandra Besselberger. I work at the University of Maryland. I do photochemistry modeling of rocky exoplanets, and I'm especially interested in haze formation. And I'm going to do some model development on the haze scheme of the photochemistry model that I'm using, and also I'm looking at the potential of hazes to cool planets.
Hi, I'm Blake Pantoja. I'm now at Bucknell University. Was in Chile for some time before, and I work on high contrast imaging of radial velocity companions. So trying to follow up RV trends with high contrast imaging to try to find the low mass companions. So I work with data from SPEAR and MagAO and trying to do this sort of thing. So it'll be interesting to apply to space telescopes and all that.
I'm Narsi. I have an instrumentation background for near-infrared interferometry and opto-optics. So our focus is like imaging disk surrounding stellar objects, and also I'm interested in exoplanets with new prospects at the Stewart Observatory on like MAPS project on MMT and LBTI.
I'm Matt. I'm an undergraduate student from Wisconsin. I saw Maggie give a talk on WFIRST like 2 years ago, and I was really interested. So here I am.
I'm Tomás, I'm from Portugal. I'm doing my PhD on study of atmospheres on exoplanets. I will be using Keops data for photometry, that's be washing soon. And I'll be using also spectroscopy for express light VLT to try to characterize the reflected and transmitted light of exoplanets. My background is half theoretical cosmology and half M-dwarf characterization of spectroscopy, namely temperature, metallicity, and things like that.
I'm Yoni Brady. I'm a pre-grad student, baccalaureate researcher at Goddard. I guess I don't really know what I do because I do all sorts of stuff because I don't really have a program yet. I have some experience doing James Webb direct imaging simulations, as well as lots of like test stuff. So leading off of the James Webb direct imaging stuff, this looked really interesting, and I'm glad it's happening.
Hello, I'm Gabby Sousa. I'm also a postdoc at Goddard. I do modeling of exoplanet atmospheres, so I'm really interested in spectroscopy, phase curves, etc. But definitely looking forward to learning more about direct imaging.
I'm Angel Tanner. I'm at Mississippi State University. I used to work at APL. I've done lots of different types of extrasolar planet studies, radial velocity transits. My main love, though, is direct imaging. I've done direct imaging at Palomar and Keck. And yeah, I'm excited about learning all these different techniques to help my students. My students have some AGAO data, so yeah, it'll be fun.
I'm Leonel from PhD student at Princeton University. I'm doing weapon control and ESF subculture, so I can try myself in WFIRST.
Hi, I'm Malavika. I'm a PhD student in University of Liège, Belgium. And I just started my PhD and I'm going to be working on developing deep learning tools for exoplanet image data on GWST. And so yeah, I'm excited to be here. Exoplanets is still new to me, so I'm excited to learn more.
Hi everyone, my name is Mia. I am now at Princeton, 5th year PhD student. I work on star-shaped image simulation and image processing.
I'm Michael. I'm 5th year at Cornell in astronomy. I'm more known for like my previous work on dynamics, but recently I also worked on Kepler and WFIRST light curves for like microlensing. And I also spent 2 weeks working on the GPI images with Clip and Loki for a class project.
I'm Tana Schneiderman. I'm a 4th year PhD student at MIT. Pretty broadly, I work on exozodiacal dust with a focus on direct imaging, although I do some detections with ALMA. So.
Hi everyone, I'm Janelle. I'm a postbac as well at NASA Goddard. And I work on the WFIRST team helping with the data challenge. And more specifically, I've been working lately on the simulation of ExoSODI, working on the ExoSODI for the data challenge. So,
all right, thanks a lot. We have a great crowd, I guess, very diverse in backgrounds and you know, places to live, places from, I would say. So it's great, and genders, I would say. Very happy. So I just want to say also that we're going to be using the Slack channel. I think at this point everyone is on there. Some people, so I made this channel for today and tomorrow. Some people might be connected from our remote participants, but they're on the Slack channel. So this is not, this is just to ask a question if you can find the data. Also, to ask a question when we're not together anymore later. Someone might be able to answer, So, and in general, we're going to use that also for the real data challenge. So yeah, there is a place. Everyone is basically everyone that ever participated to our staff. Different hackathon that we've had, and the people that sign up for the challenge. So it's also a place where you can maybe look for team members if you want to make a team, if you don't feel like doing the challenge on your own. But okay, today it's even better to meet people. Yeah, so yeah, we had one channel for the first hackathon, second hackathon, etc., etc. And I made one that's called teaming up. I don't know if it's going to be used, but for now we use this one. Yeah, so let's move to the presentation. So okay, so Maggie already said a lot about the mission, so I'm not going to say too much. And the team, I would say, you know, so we have Maggie from SETI and SETI/Wisconsin, and then there's a very strong participation from NASA Goddard because Neil is done a lot of the simulations, and there is a strong participation also from JPL. Sergi has done Starshade simulations, and he's not able to come, but he's going to send us a video for tomorrow for the Starshade presentation. And then I would say, you know, some help for me to make sure this data challenge is a success, basically, you know, making sure that the room is not empty, and we have actually people participating and giving results, and we are basically having those kind of events to show that it's not that difficult. And, you know, even though it's an astrophysics oriented challenge, you know, we are not here to compare algorithms to the death, right? We're not here to, you know, to win, you know, signal to noise of 89 or 88. It's just the same. What matters is really like the orbital parameters you get, how correct your answers are in retrieving what's real and what's not in the images, these kind of things, you know, and maybe also analyze other things that you may encounter in the field. Obviously, if you have a better signal to noise, you may have a better measurement. But I would say to get something, it's not that hard. But you need to do a bit of astronomy to get the physical parameters. In the end, we're not comparing an algorithm, we're comparing results as if it were already a science paper or something. Okay, so very, very quickly, so WFIRST is actually real. I mean, it's happening. We are still a bit scared that sometimes that the chronograph gets dropped. So it's still very important, you know, like Congress committed a lot of millions to make it happen and keep going. And so right now, the mission has passed the preliminary design review. But for a space mission of that size, so it's, you know, several $1 billion, you know, it's not that much smaller than James Webb, if you think about it. For a mission of that size, it's not just a design, you know, there are a lot of test bed and hardware that is already developed, you know, it's not, so in fact, a year from now, it's supposed to pass the critical design review, and then you start cutting metal and building the spacecraft, basically, so correct. That's right.
Yeah, so
it's a really important time, basically, and it's actually a good thing that if we show, you know, modestly what we can do as a community with this mission.
We just passed the preliminary design review for the chronograph and for the mission, right?
The mission will be later in this month.
Okay.
But yeah,
so for the chronograph, which is a huge milestone for the chronograph, and I guess moving from phase B into phase C is expected early next year, early 2020, like January or February.
So of course, for this data challenge, you know, we assume not the most optimistic scenario, but not the most pessimistic either. We assume that things go reasonably well, and some of the technical and hardware challenges are solved by the time it launches, obviously, you know. Okay, so, and it's an aggressive schedule. So if things go well, you know, we're talking about the end of 2025, which is really soon. You'll learn that it's really soon. Time flies. Anyway, so on the website, in the link tab, I also put some links of maybe the 3 main web pages about WFIRST websites, you know. So of course you have the one at NASA, the one that was flashing before. It's kind of like the official one. The one at IPAC. So IPAC is going to be the place where the coronagraph data is analyzed. And Space Telescope is going to be where all the data from WFIRST is actually archived, and the scheduling is done for the wide field instrument. So those places, I mean, you can visit them. Those sites. It's a little bit redundant, but they each have their own things. For example, if you want like specific chronograph simulations, there are some available on the IPAC website. If you want some PSF tools, for example, or things like that, or the footprint of the field of view of the wide field camera, different things like that, it's usually on the Space Telescope's website.
We're recording all of this.
Sorry?
We're recording right now, right?
Yeah.
All of this?
Yeah.
Do you know what our sound capability is?
I have no idea, but I think, you know, so the camera is catching this, the whiteboard,
okay,
the screen, and the person, I think, up to here.
Okay,
more or less.
great. So this is all going to be recorded.
I don't
and we'll
know.
Post it.
Yeah, so things are recorded, and we also have a few pictures. I hope everyone is okay to have pictures taken.
Tell us if you're not comfortable with any of that.
I forgot to ask you. Okay, so the aims of the data challenge is to broaden and deepen the knowledge of the exoplanet community. So, you know, exoplanets just got the Nobel Prize, you know, to a couple people, so it's not really a toy science anymore. It's kind of a serious business now.
They say once a field wins the Nobel Prize, it's over.
It's over? Yeah, okay, so probably maybe this was
You're at
before.
the images, just started.
Maybe it was before, but maybe you're right.
Yeah.
Yeah, okay. But here we're talking about reflected light, relative reflected light, you know. Anyway, so, and we want people to get acquainted with the data, because the data is a bit different from a ground-based AO data. It's not the same contrast regime. It's not the same frames. It's actually visible light. It's EMCCD detectors in photon counting mode. So it's really different. And then, you know, by doing this kind of exercise, participating to data challenge, or using the tools so we're not like advertising certain tools. We just, like, for convenience, use some. You can use anything you want to do this challenge or this exercise, right? But by using those tools that are publicly available, we actually find bugs or find issues or improve the documentation or help people, you know. Juneli, for example, she started from scratch with Orbitize, and now she's actually attending the meetings of Orbitize because, you know, because of the hackathon we had in LA, and Sarah Blunt, the developer of Orbitize, participated. Now they're trying to put together radial velocity and imaging epochs together in the software. So it's actually you know, a good catalyzer to have people work together and solve issues instead of working on their own. And then obviously we want to train future exoplanet scientists, people that know not just one technique, but several techniques, and not just the ground, but maybe ground and space, etc., etc. So yeah, you know the website, you know the timeline. So basically the new data, so everything we're going to do today and tomorrow, it's on data that we had prepared for the previous hackathon. And the reason why we do that is that we also have this event before in the Spirit of Rio conference in Japan on Sunday. And we want to have everyone on the same starting point. Basically on Sunday night, we're going to release the new data with the new exoplanetary system. But it's the same format and, you know, the same kind of questions. So using the tutorial stuff that we have those 2 days, it should be the same, more or less, except maybe for the exozodiacal light simulations which are a bit more advanced in the new data set. But this is just a picture. We see me. So this was the first event at Space Telescope in Baltimore. So this one was a bit pushy, you know, because it was the first time, and then we had one in LA, and it was much better. You see, but the difference here also is that we had some pretty strong high contrast imaging experts in the room, and also we had the developer Radvel, we had the developer Orbitai, so it was pretty efficient one, I would say, and we got a lot of feedback on the material we have. Okay, so we are talking about 6 imaging epochs, 4 done with the hybrid LEO coronagraph and 2 with the starshade, assuming that in some years there will be a starshade rendezvous, and so the mission lasts for more than 5-6 years. The target, the science target, is the same for all the data set, the previous one and the new one. It's 47 UMA for many reasons. And then you're supposed to find at least one planet that has matching imaging data and precursor radial velocity data, which has also been simulated. It's not a real signal for now. But everything is made so that when WFIRST flies, you have this kind of data because we're not going to observe any target. If you spend 100 hours on a target with WFIRST, you're not going to just pick any star and go fishing, right? A target that's informed. So then the assignment is to extract the sources, and when you're convinced that the source is co-moving, so it's bound to the star, you compute the photometry and astrometry. That's pretty classic. If you had found an exoplanet direct imaging, you would do that. You would try to do that. The problem is that there are some contaminants. We injected possible background, foreground sources, and also the coronagraph is so sensitive that you are sensitive to exozodiacal light from the system. So you're welcome to also analyze that. It's a bonus question. So for the hackathon, we had different entry points. Some people started on the non-coded frames. Some people started on the directly from a table with measurements of a couple planets and tried to do just the astrometry and the orbital feeding. Well, I mean, just the orbital feeding. And some people, they started on the PSF subtraction and so on. For the data challenge, everyone is doing the same. If you don't know or don't want to do one part of it, you team up with somebody that. And I would say that the PSF subtraction part is actually quite easy. And we are here to show you at least possible tools you can use to do the rest, but not with too much details. Yep.
First, what is UMA, the unit?
UMA?
Ursa Majoris.
It's Ursa Majoris.
Probably should be a capital M.
You're right, it's a capital M. I'm going to correct it right now.
And you could put disentangled
I corrected it.
background sources, not with background sources.
It's like writing requirements.
Okay, so now it's me that is doing the
disentangled from background sources.
Okay. All right.
And also, for the images, you mean we won't work from the photo counting images? We only have the...
No, the co-added. Yeah, because we think this step is going to be figured out on the ground. Don't need, I mean, we need people like you to figure it out, maybe, but not for this data challenge.
Can you talk about the range of WFIRST coronagraphy with respect to radial velocity range?
What do you mean by range?
My understanding is the radial velocity is close to the star. Like radial velocity detects the planets which are close to the star.
Yes.
And the inner working angle of the WFIRST is, I think, I don't know, like more than like
0.15 arcseconds is the smallest. Yeah.
You have for the radial velocity.
Yeah. So Neil is gonna show this. Actually, I don't have this plot, so it's good that you have it on my presentation. So it's gonna talk a little bit about the parameter space. What you ask is correct. Some let's say some planets that are too far away, they would be, you could image them with the coronagraph or the star shade, but maybe not detect their radial velocity. And some planets that are too close, it's the opposite, right? So you're right. I mean, there is a sweet spot where you can use both techniques, and that's what we're trying to investigate.
All of the targets that we'll be doing the tech demo phase on are already known to exist by radial velocity. So they're in like 2-year orbits.
Yeah, so we will, as I say, we're not going to go fishing with WFIRST. So we're going to use data targets that have a lot of years time span of RV data with trends, and targets which are close also, so you can separate, in AU as much as possible with the same working angle. Working angle is 0.15 to a bit less than an arcsecond, so it's a tiny space. And yeah, so the last thing I'm going to say is that it's reflected light, and so depending on the position of a planet in its orbit, you don't see it as bright, just like the moon. It has phases. And so it means also that when you look at your different epochs, you're going to see flux changes. And so if you do your photometry correctly, you can derive a phase. You can derive a phase curve and even an albedo for that planet. Yeah, that's also a new kind of astrophysics that we're trying to show that we can do with CGI. CGI is the name of the coronagraphic instrument. Okay, you don't forget to remove it here. Anyway, so this is all the modes of the CGI instrument before the last review. The IFS is not there anymore. As of now, it's going to be replaced on the same detector as the imager by a slit. So they will have slit spectroscopy, not IFS. And that's to save mass and save money and probably save time. So it looks complicated, but in fact, you just have a hybrid coronagraph, and that's the only one we're going to use in this data challenge. And then you have shape pupil, and this was designed for characterization and spectroscopy. So forget about this for now. And then you possibly have the star shade. So the data challenge basically considering only these two modes, and it's only considering also the shortest wavelengths. So for the hybrid LEO, it's centered at 575 nanometer. So it's pretty low wavelengths. And for starshade, it's even lower, right? I didn't. Yes. Okay, and then the observing scenario. So all the data we are showing here is using the observing scenario OS6. So there will be new observing scenarios in the future, but right now those are like the most mature simulations that we have from JPL. So it's actually taking into account all kinds of things, residual wavefront corrections, jitters, things like that. And so this would be the wavefront, the speckle field. So this is in the focus. This is not a pupil image, right? This is in the plane of the coronagraph. So you see of the detector. And you see residual speckles, and this is like a pessimistic case, and this is an optimistic case, I would say. So basically the contrast that WFIRST is supposed to achieve is going to be this or somewhere in between. And we're talking about, 10 to the minus 9, 10 to the minus 8, maybe, or something like that, after post-processing. And so then what I'm showing here, this little cursor moving, you see that the waveform changes, the waveform residuals changes once in a while. And that's because we observe the reference star at AUMA periodically. So in fact, it's the reference star for 2 hours, and you dig the contrast. You dig the dark hole, so you basically make your waveform control loop, and then you do the science star. You roll the spacecraft, the science star. You go back to the previous roll, science star, second roll, and then you repeat this 13 times. So it's in the end, it's a lot of time on all together to achieve, the contrast of 10 to minus 8, 10 to minus 9. Yeah.
So this is all part of the the science team reserved program to do all of these recoveries of known targets.
So no, well, it's not 100% clear how it's going to work. Right now you have
to propose 140 hours to do this. I feel like that would be Hubble wouldn't give you 140 hours to do that.
Yeah, but it's a different different way of observing now. Just like people for extragalactic science, people ask sometimes for 50 hours of Keck or VLT, and then they stack up all their IFS data to see a redshift 8 with a signal to noise of 4. We're getting there in direct imaging. So it's not this, it's not a snapshot anymore where you spend an hour and a half and do ADI and you get better pictorial speed. It's not like that anymore.
So that's good, right?
Sorry? Yeah, it's good. But the time is not going to be exactly open at the beginning. It's going to be like something like commissioning and participating science program with people that are heavily involved in developing the things, and then maybe it's going to open.
Yeah, and this during the tech demo phase, where we're carrying out these observing scenarios with reference with both RDI and ADI, the reference star and the roles. That'll all be sort of pre-programmed in with a team that is different from what the current science teams are. We don't just, I have this team and Bruce McIntosh has his team, will be disbanded in another year and a half or so. And at that point, there'll be some kind of participating scientists that come on board to probably dive more deeply into just the post-processing of all this stuff and really planning out the specific observations that have to happen within that first year and a half. And then those participating scientists will be with the mission through launch and through the technical phase. And there will be, we're imagining there will be also a GI program where investigators can come in and produce their own, assuming the mission is up and running and doing it.
Yeah, so I would say it may seem a bit far away and a bit like you're not part of nobody is really part of the actual team yet. It's just that by doing this kind of data challenge, you get acquainted with it, and you're among the few that actually know how the data is and what to do with it. So it's a good way to jump in, let's say.
Sorry, the RDI is row differential imaging.
Reference different. So what we call RDI, reference differential imaging, is just like you have a science star and a reference star.
Okay, I see.
And you subtract. So it's the old-fashioned way, let's say.
Okay.
We have a fancy acronym. And and ADI is the ADI on the ground is that you stop the derotator and you just get like a diversity in. Your field rotates during your observation, so you can basically subtract a median PSF that's built from your own data set, right? To retrieve your planet. In space, you don't have that much angular variation. Usually, it's a few degrees. For James Webb, it's 11 degrees maximum. For WFIRST a bit more, I think.
13 degrees
Yeah.
or something, plus or minus.
Yeah, plus or minus 13 at most, depending on where you observe. So we do rolls. So it's just.
They're rolling to simulate ADI.
Yeah, exactly. So it's an active ADI.
Well, rolling was the first ADI. So I think I've seen the rolling being called RDI. So there's two.
No, so
usually it's the ADI.
Oh yeah, you mean like roll differential imaging?
That's what I asked.
It was RDI. So
Yeah, so I agree with you. RDI was
RDI and RDI.
RDI was invented by
I don't know what the R would stand for in that case.
roll. Yeah.
Okay, well, to differentiate, we're calling it angular, rotating,
ADI, yeah, ADI.
and then reference star.
Ground-based ADI is a little different than roll ADI.
Yes, because it's yeah.
We don't roll.
Anyway, no, I agree with you. People that work with Hubble in particular, they don't, that was before ADI, I would say. ADI was created for the alt-azimuthal ground-based telescope, and it became so famous as the acronym that when we started to say, hey, why not use a separate star and call it reference differential imaging?
Yeah.
I know where it came from. It came from my office with Dimitri Maway, so I know exactly when it happened. So started to write this on papers, and then people started to pick it up.
So with the rolling, is it just between two angles pretty much that you're just switching back and forth? So
yes.
You're dealing with just two angles, I guess.
So you can imagine that if you only have 10 or 15 degrees roll, it's not that great to image a planet that's really close, Yeah. So it's kind of a safe net to image something that's a bit further. We do the same with James Webb, right? We only have a few degrees of roll, but
a lot of the early imaged brown dwarfs were with Hubble, rolling the eye.
Just call it angular for the.
I think they call it roll. They call it. I think.
Angular implies a continuous angle. This is
Just
Yeah, you're right.
There's
So,
like a few SDIs too, or something.
so I call it active ADI.
active.
Because you roll, you make the ADI. It's not natural. It's not from the parallactic angle, right? And yeah, and I call it roll PSF subtraction, not roll.
Second of confusion about this until just now. So I don't want to plant confusion in people's minds who have not been exposed to that. We'll just call it RDI is the reference star, angular is ADI, where you're rotating the field
And
angularly.
There's a capital M at UMA. Anyway, I changed.
What makes the good reference star under diameter or?
That's a good question. So angular diameter, in principle, when we get to like crazy contrast, at some point, resolving the star would be a problem for high contrast. It's not the case for WFIRST. We have a 2.4 meter telescope, and I don't think I asked. At some point, I asked, and the star diameter doesn't influence your contrast as long as you don't resolve it really. If it's a star with a shell, you're not going to use that as a reference star. No binaries, obviously, and in this case, actually a brighter star, so that you can do the same but faster. You don't want to spend even you already spend 26 hours on the reference star. You don't want to spend more than that. Okay, so we are talking about electron multiplying CCD in photon counting mode. So the frame, the raw frame looks like this. You almost have nothing there, and that's assuming that your star is so well centered behind your coronagraph that there is no jitter, almost no jitter left. So you only measure a few photons per frame, and then sorry, I'm in front of the. Yeah, and so then when you actually pile up and co-add all those frames, you start seeing your speckled field image that you're expecting from a coronagraph. Oh, thank you. So the data that we're distributing, they look more like this. We are not giving you the raw. So the background that you may have in the image, there is some extragalactic background. So if you detect something that's not a 0.5 point source, it may be, and that's not co-moving, that probably is in the background. There are some, we consider a certain stellar density also for this direction in the sky. So you may also encounter stars, which are not planets, but point source which are not planets, let's say. And then the exozodiacal light, we modeled an emission, so an inclined system, an inclined disk basically around the star. And so far, most studies looking for this have been not so successful, like there are a few that have been detected, but it's, let's say it's difficult, you need high contrast. In the case of CGI, it's going to bother us. It's a contaminant for characterizing the planet. So in fact, if a star is known to have a high level of Zodis, it's probably not a good target to look for planets because it's going to be completely embedded.
But then in that case, it becomes a different kind of high priority target because the disk studies themselves are actually, the disk studies are a guaranteed science harvest out of this project. I mean, no matter what happens with the planets, being able to directly detect disks in reflected light in these older systems would be a major outcome of the mission.
Oh, sorry, go ahead.
Do you, in the observing strategy, is there a maximum ZODI level that you're sort of setting as the, because there's obviously the ZODI with thousands times of our own solar system.
So are these systems not that high,
so
like 15 or 5 or something like that?
I don't have the.
We're on the.
You mean as far as target selection?
Yeah, what's the cutoff on the target selection? Which ones are you?
The science teams that are interested in disks will probably go after the bright ones, actually, because they'll be the easiest to study. If there's evidence of bright debris, it's probably not going to be the best target for recovering RV planets.
Yeah.
But as far as I know, we don't have enough prior information about the known RV systems to know in advance what we'll have. So we'll probably be surprised by most of these.
Okay.
And it's going to be a surprise, and it's going to be a surprise convolved by the PSF, right? So, so it's not that trivial to recover. In the case of the hybrid LEO, it's not that bad. In the case of the shaped pupil bow tie PSF, you see some weird. You can see.
I think it's not expected that the RV targets will have thousands of Zodis around them, though, right? Because they're nearby bright, well-studied stars, so they would have been, something would have shown up, I would think, in one of the surveys.
Yeah, I'm mostly just interested because I know that some of the work is suggesting that even past 50 Zodi, you might not be able to see the planet. So I'm wondering if in the observing strategy it's already built in, what level of dust you sort of just move on.
Yeah, I think it's just down to the detection limit of whatever survey is available. And I don't.
It's really an open question that teams are actively looking at. I would say.
Yeah. Well, and it's so hard. I mean, a lot of these disks are more easily detected in longer wavelengths, and then to try to translate that into what it will look like in optical wavelengths is very uncertain. So I think it's inevitably it's going to be a surprise.
Okay, so a few parameters, technical parameters, like we give basically. So all the imaging networks have the same pixel scale, 21 mass. And the filter bandpath, you see it's a slightly shorter wavelengths even for the star shade. And both case are 360 degrees suppression detection zone. Those are basically modes to look for new planets or look for planets that have never been imaged. And then the working angle, this is quite important because for the LEO coronagraph, it's only 0.15 arc seconds to 0.5 arc seconds. So, but the star shade can look much further out. So that's also something to consider when you do the data challenge. And so, okay, so it's 47. Yuma is the science target, and the reference star is Eta Uma. And so the science target is at 14 parsecs, so it's a very nearby star. High proper motion. So proper motion are pretty high, and that's actually helping you to disentangle background star without being, necessarily super precise on your astrometry at the beginning. So this is the simulation that we did for the first hackathon, and that's the image you can see online. It's actually 4 epochs like this and 2 epochs like this, but I just put 3 just to show you. And the blue dotted line is basically what you're supposed to find. So in this case, there were 2 planets, and you can see that the planet is getting fainter as it orbits here. Okay. And in the star shade, you can easily see that planet, but this one is like super faint. You can see it too, but it's pretty faint at that position of the orbit. Okay, and that's why one of the things that you can retrieve, and that we will be asking for the data challenge, is to get a phase curve like that. This is the input phase curve. And the other thing we are asking is an orbit of whatever you find. So this was done by Junelli with little prior knowledge of the orbitized package. This was done with 4 epochs. I think this was the first. Mm-hmm. Yeah. So this was done with the 4 first epochs. And so yeah, you can do a decent job, because the epochs are spaced in time. If you had a way to combine the radial velocity and the imaging epochs, you could do even better. So in fact, at different levels, you can answer the data challenge. Some people might go further in astrometry than others. Some people might go further in characterization of the exozodiacal light. I don't know. It's pretty open, and we're gonna, we're hoping for unexpected analysis, basically, in this case. Yeah.
No question. While I'm thinking about it, Maggie, you mentioned you guys are going to be using targets that have RV data. What do you think you're going to be able to do with Gaia by then?
Yeah, astrometry is another thing we would like to fold in at, maybe for future challenges, because Gaia.
Not even just challenges when you guys launch.
Well, yeah, and for the actual mission, you will.
This is a really good question. I addressed it at the last slide. Basically, for this data challenge, this year, basically we don't do any Gaia, but except maybe for the proper motion that are Gaia corrected or something. But in the future, yes. I mean, all the targets will have.
You may have orbital information, so you can choose when to do your observation.
Yeah.
In fact, we hope to get the data release 4, and all kinds of information on the targets.
When does the R4 come out? I can't remember.
I think it's supposed to be before the very first web. I don't know.
Early 2020s, I thought.
This is data release for the Gaia mission that we're talking about. So actually, being able to determine when the best time is to do the coronagraph imaging is really what's motivating trying to recover a lot of these systems in radial velocity space with NUID, because we don't know anymore. Like, we've lost almost all these planets. I mean, we know they're there, but we don't know where they are in their orbits. The uncertainty that has accumulated to the point where we have no idea when to actually point the telescope at these systems in order to make sure the planet will be visible. So between now and launch, we need to recover them with the RV, and also, scrutinize them within the Gaia data.
Okay, and this is the precursor RV data. So this was for the second. So it's not. It doesn't correspond to this one, but this was for the second hackathon. And you have basically a signal like that. You're giving a list of points like that, and it corresponds to 14 years of cake-like RV data with 1 meter per second accuracy and 4 years of NUID-like accuracy, 0.3 meter. So basically, you have the KEK and then you have the NUID, and we're assuming that the calibration between the two is solved. You know, we're not. We hope that you could use all this time span with this data, and this is beyond the scope of this data channel. It's not just on radar velocity. But basically, just by looking at this curve, you can sort of guess what's there, right? If you're an expert. You know? Blake, what do you say is there? How many?
Two planets.
2 planets, yeah, because you can see it's like a combination of 2 sine functions, probably.
So you see the one planet on a shorter period there,
Yeah.
and then an overarching up and down trend. That is the second planet, the longer one.
So another question that's interesting, and we're going to ask for the data challenge is, if you only had 2 epochs, so in fact, this is probably the number 3 or 4, right? But if you only had 2 epochs, you know, would you be able to to do an orbital, to do anything, you know, with radial velocity and just 2 epochs? So we're going to ask the participants to also provide their solution with less information, because we might be in those shoes, you know, when the mission flies. It's pretty unlikely that we have 6 beautiful epochs of everything, you know. So, and at the beginning, you know, if we could start to see a point source and it's co-moving, you know, we're gonna want to do the science with 2 epochs. So yeah, I don't know what's going on here. Okay, right, I'm missing a slide, but okay. And sorry, so I had the solution basically showing, but I can just put it up here. It's here. So this was basically the input for this RV data set, and you can see there are 2 planets, but there are also 2 that are hardly detectable by RV, and that's something that's interesting. So the real data challenge is not necessarily going to be like that, but you have to consider that some planet might be detectable by imaging and not by RV. It's possible, and that's what your question. That was your question, right? So the timeline. So we are right here. We've done all these, and then we give basically 2 months from Sunday to Christmas for you to solve this challenge. Frankly, it's not a full-time job. I think if you've you know, played with the data before and you team up, even if you don't team up, I think you can at least answer some of the questions in a few days of work. You know, I think we'll see how it goes. You know, if people are like, we haven't done anything, maybe.
What are the prizes?
What are the prizes? So your weight in gold. Your weight in gold found on this exoplanet.
We have funding, so we do have funding to send people to one of the major exoplanet conferences next year to present what they came up with.
So this is still TBD, you know, but we were thinking of trying to get a talk at Exoplanet 3 conference in Heidelberg, maybe a talk where we talk about like everything we learned from the data challenge, and maybe a talk by the winning team. But we have to see if it's possible, you know, to get like a team session.
At least do like a plaque.
There are other venues maybe.
Yeah.
And then you know, like if you spend significant amount of time and develop some methods, and even if you don't use your own package, but you use a given package that exists and you interface it for this purpose, I think it's interesting, and you can publish that. That's
we could conceivably have more than one winner too.
Yeah.
I'm actually expecting that, because I have a feeling people will come back with science results that are kind of complementary. You know, if people emphasize, you know, the exozodi versus some other aspect of the data, it could be.
That's why we're not showing exactly how many points you get for each question, because we want to see what we get, you know, and if something turns to be super easy and everyone gets it, you know, that's probably not the thing that discriminates, you know, the winner. But we want to see, you know, what people turn in basically.
So by kickoff, you mean that the data gets released Sunday?
Oh yes.
So everybody starts.
No, I mean, originally we had one kickoff event, and this is the launch of the data challenge. But in the end, we have two in two different continents. So the kickoff is basically from today to Sunday.
Yeah.
Okay, so these are the events. I don't think anyone is participating to both. I am.
Are you guys?
Actually, the three of us were going to Japan. Anyway, so as I said, you know, we have a Slack channel. I'm talking about the outer space. We don't use it, and this is too difficult to get access to. And yeah, so future. As I said, you know, the IFS has been replaced by probably a prism spectroscopy, so that could be a topic for a data challenge. We could have a data challenge on disk, you know, extended structures specifically, and we could also have the same kind of data challenge, but going even further, including Gaia DR4. So that's basically the question that Angel had. And then obviously we can update the observing scenarios as well and so on. And there was, I must say that there was a data challenge that was done, organized by Maggie a couple years ago. But it was a spectral retrieval, right? So I'm thinking more like atmosphere retrieval. So I don't know, I was not involved, but I think it was pretty hard for people, right?
Well, the issue there was that there really weren't very many people in the world who were set up with spectral retrieval codes that could work with planets seen in reflected light, because they were aimed at thermal emission. And this is such a different realm that I think when we return to that, which hopefully we will, there will be a lot more teams capable of participating in that. I think a lot has happened since then, but that was a good catalyzing event for people to sort of realize we need to get going on that.
All right, so I think we're already very much behind schedule, so I'm gonna hand, I think we should.
I would suggest we skip mine.
Really?
Go right into the software
installation
part, because you covered so much about the data.
Okay.
I'll whatever is missing from yours, I'll cover in the 11, 15.
Okay, okay, that's a good idea. It's a good idea. So in any case, we can post it on the box folder so you can see it, and on the website. So if you want like slides on simulations, you can go to those. So we're gonna go to this one. You mean? No.
Software.
Oh, sorry.
1030 part. Yeah.
1030 installation. Yeah. So this is just setting up basically.
We should let people take a look.
So yeah. So I don't know. Yeah. Okay. I send a list of things that would be good to have, but it's, you know, I know it was a short notice and so on. We're also a bit on short.
The time of our coffee hour is not quite that flexible, because I think why do I think she was putting it in?
So I think it's a good idea to have the coffee at 11, which is in 25 minutes. And meanwhile, you can check your installation and ask questions.
Schedule we're on for coffee. So
sorry?
I'm just going to check and make sure that is the same time that they are going to put the coffee out.
Yeah. But that's something I checked with her not so long ago. But maybe yeah.
I'll be right back. But yeah.
Okay. So
Someone on WFIRST CGI, WFIRST CGI PC.
Are you running Windows or are you running Linux?
Linux.
Okay.
Why is that?
Because PTMC doesn't seem to work on Windows, and it's a dependency for Orbitize. And I didn't manage to set up a kernel on my Linux desktop.
Oh, he sent it to us.
Oh, okay.
So I was wondering if anyone.
What is PTMC?
It's one of the dependencies for Orbitize.
Okay.
So
What does it do?
I'm not certain.
I learned the hard way.
Yeah, that was the only thing I wasn't able to install, was hoping somebody who had Windows would.
So then it's a Windows problem.
Are you using
because
Linux
Tiffany
subsystem?
had that problem, so maybe it's a Windows thing.
Oh, interesting.
Try the subsystem.
No, I haven't. I wanted to try to set up a kernel on my desktop, a remote kernel on my desktop, but that did not work.
You can install like a mini Linux inside Windows. Have you tried that?
No. Could you send me a tutorial or something? Oh, I see we're using computers.
Mine's Windows. Sorry, mine's Linux. So go to your so go to your search bar. Windows features. Search turn on. Yeah, I have them. I should have it. So fine.
Soybean, we're talking, you can use.
Oh, you could. Oh no, it's okay. It was fine. I just slept. It was fine. It really was. And I just got a new computer. So I moved out from yeah, no, it's okay.
PTMC.
PTMC.
It's kind of sketchy, yeah. But it's okay. It was good enough for me to sleep, and then I moved this morning. They gave me a new room, so I'm good now. But thank you. What's your name again? Sandra. Sandra.
I know.
Oh, so
Thank you for Sarah.
Oh, wait. Are you a first year grad student?
Yeah, so.
No, actually, Peter Bostock, sorry, yeah.
Can I see like what the error?
Yeah, so I did search this before. So
And I was
it's,
wondering like if I had seen you before. Okay, do you recently start there? Or have you been there for long?
Oh, okay.
Okay. Oh yeah, then.
Yeah,
Okay,
so
then
it's
probably yeah. That's why
I will try this.
Yeah.
And then
Sorry about.
No, it's okay. Thank you though. No, we're good now. Thank you. It's okay. Yeah. So sorry. What's going on with? Yes.
It's just that so one of the dependencies.
Right.
I can actually. I think I actually saw that somebody tried to contact. Tried to contact the.
Oh no.
to fix it, and they just didn't get feedback. So, like that was like.
Just for the software installation.
I'm not sure.
Okay, because I can message her right now. No.
It'll be okay.
I'm sorry. I hate when that happens. Like, you just want to get something done, and then it's like, oh,
Yeah,
not
so.
today. Unavailable for 30 minutes.
You're writing your thesis proposal?
Not today. Yeah. Matt is good about not accidentally like starting.
No, it's really horrifying.
Okay.
Okay, so.
Windows.
Oh no, WFIRST. Oh, this is
Yeah.
Sorry.
That's what he was.
Yeah, that's
Oh,
right.
yeah.
That's right. Yeah, exactly.
He is still cute, but not cute.
Aw.
I'm not sure.
Yeah, I guess I should go ahead and look at this.
There's others.
Yeah.
Did you ever use MC?
Yes.
Okay.
So I think the problem is that there's something in the parallelization because for some reason Windows doesn't play nicely with the parallelization in MC. So I think PTMC, there's something in there that maybe that's where it breaks. I'm not sure. Yeah, I usually use my Linux desktop.
Is that how you write it? I can't remember.
Do you have a virtual machine?
No, I don't. Although this is gonna be exciting. How do you write it? Sorry. PT.
Yeah, I mean, what you guys are showing.
Yeah. Okay, mobilizing the orbitized team. Hold on, they're gonna. Someone's gonna get back to me.
Full recovery. Not all the way. All the way. So
On
in
Windows,
both
'cause I don't
of our,
think I had an issue.
I think it's just on Windows.
Okay.
no one got all the way.
Yeah.
So you can't.
We've done our own, like,
Is that the issue?
I can't answer.
Oh,
that.
okay, so, yeah, so, maybe you have Anaconda already, and then VIP and or Pike. I already have VIP, I actually don't have Pike. Ties and Rat. So, yeah, I've never used it either, but I do a little line there. I'm not entirely sure what it even is. Binary parser with the declaration.
Cheers, but
Sounds
I'm like, they're Slack, so I'm like asking if they know.
I'm sure it's like, no, I already had it.
So, to see if I just had a little bit of
Oh no, just talk about this Windows installation because the Windows installation. Yeah, you should be fine. You could ask them, but try installing Orbitite. Yeah, I don't think you've
So if you Google like a video.
Already have the ideation.
Maybe. Yeah, I don't know.
They're probably thinking about it or not.
Information HR 879.
But I have to.
I'm starting also.
Yeah, I have to.
So this is like.
Yeah, so
probably.
I would usually start with
Yeah, so that's. Yeah.
I installed it all right. Yeah, so I guess something.
Well, it seems like everything's pretty nice.
Are you one of the writers of it?
I'm not one of the writers, but I have been helping.
Okay.
I'm actually
I'm
writing.
like, I actually took the idea to use.
Yeah, maybe this plugin is something if you're on the absolutely.
Nobody went that far.
So, I would say run that first. I don't think it works with cons. So that's for developers. But I think, yeah, that
So it's like two different installations.
Have you used Pikelet?
I think also you can just like clone it and then run Python, like install, like set up WY and then.
Yeah, so do I. It's like, once you have it working, you don't want to mess it. Yeah.
I know it's.
I'm getting an arrow ties here.
Yeah, so does mine actually. I still don't use 3. There are some packages that still aren't in 3, so.
Oh, like COS.
Yeah. Yeah, that's. I talked to her yesterday. Actually.
Oh, yeah. Is it like
Yeah.
I went to Silver Six. And then I had like an hour sleep and then I took a train here.
Yeah.
So
Oh, they are?
I know, but like
Other things.
it was so much more
Talk easier.
like because of like traffic, like
It's when you went to that
So it seems maybe things are moving. Oh, it is, yeah. It helps.
I feel
Well, I might as well install it anyway.
I haven't used Rapid, so I'm like completely new to it, just a few.
Yeah.
There was no, when you installed, I'm not like,
How is that working?
Remember I saw something today. I tried to.
yeah, right, that's what I never ever do.
So that didn't run.
It ran and at the end it's Thursday.
Oh, are you getting some like not enough angle error or something like this? Still? Yeah.
Is it because the OS is very new, or is it?
You're suffering, yeah.
He's installed for me.
Oh, no, I meant the OS.
Yeah. Oh, I don't think it's been updated.
Oh, really?
Yeah, because it's still something. I'm trying to remember because I looked at that too, and it still looked a little strange. But
Orbitize? Orbitize has already abandoned tutorials online. I'm basically just presenting
So
version of that, tailored
for me,
but
I was
it's
looking at yours, and there was something. Yeah, with the 180 minus it was sort of working.
no, it's actually gonna be very tailored. Like we'll have the tutorial is just running through the books.
Yeah.
So tie up with some experience.
Yeah, exactly.
Yeah, let me see. Where's it
I'm gonna try to
So
I
I'm gonna take another look at that because I remember the subtraction still looked a little weird with it.
Down.
You try it with PyClip as well.
No.
These are all
So yeah, try upgrading maybe fix it, and then if not, we can do the
parts like in general packages. These are like PyClip, Orbitize,
That's where I had it on.
Velocity.
Julian?
All these packages like Orbitize, radial velocity, PyClip. Yeah, in general. Okay.
So there's a Orbitize is
I see. Okay.
it just happens that we're just looking for something to use.
Is it running?
Easy one. And on top of that, the person that develops it most can use one of our there are other ones, I think.
I guess that's whatever the newest.
Hey, Julian, don't kill me, but I haven't installed one single thing yet.
Yeah.
What should I do?
Wait, Maggie, can I do it with you? Because me neither. I only have Orbitize because that's the thing
I don't even have that. I don't even have that.
I don't have Orbitize actually.
I'm
So except I have EAP and
So Dan was saying that.
I need, like, starting from nothing, including how do I get on our Slack channel and everything. Like,
That's how people have.
so far behind.
So what is that install just like the IPE and then Rappel? Or strains are all, because these I'm not using, I guess.
No, I mean,
But
this is just a course, you know.
Yeah, you the best. Is that the one that you're gonna use?
It's not necessarily the best, but it's the one I used.
The tutorial?
It's the same thing I showed last time.
You call it
Just showing the.
Is it just for?
Actually, since you have experience.
Thing, I wanna install the ones that will be shown.
The email, but then there's also.
So I think it's good.
So I installed first Anaconda.
Where are you going?
So I clicked on VIP
Oh, really?
and then clicked on the installation page.
Oh, okay, I got it.
No, this is just like, once you get all of the
I had to find where to install it.
You can
Yes, I
install
just
locally.
clicked on VIP and then
then I just hope that I never have to touch it again.
Right,
So it's.
One of these high contrast.
I think one of
And it's
each.
different.
Yeah, and then ordered something.
Yeah, I just signed a lease earlier this week.
And then,
Yes,
so the actual data.
Yeah, it wasn't too bad. I did look at a few places before,
Yeah,
but
it's
it's like
data.
pretty big, 2-bedroom apartment in
Then you
like
also
this
have
house
to
from
download,
1900
yeah,
or
so it's
something like
the
that.
box repository.
Yeah, it's pretty nice. I mean, it's a little
And then that's
older,
where you
but
download
it's,
the.
yeah, but it does have like
the
baseboard
tables
electric
for
heaters.
astrometry.
Yeah, it might jack up the
Last time for, you
electricity
know,
in
the
the
second
winter, I
I'm just
don't
gonna use
know.
that one.
But yeah, it's pretty nice, and it's 10 to 15
15
minutes to walk to work, and it's like 2 minutes from the main street of Lewisburg.
They
So
are
Okay, so it's
under
a small city, but.
yeah,
day 2
yeah.
astrometry.
I still am going to buy a car here
And
soon.
so these are the
It's, like,
CSV
hard
files.
to get around without one.
You have to modify first to like match the format for Orbitize, but then you read into Orbitize and then you work on it.
When I was searching.
Yeah, she was there last week and the week before. I actually stayed in her guest room like the first
I
week
know
I was
this is
there.
Pippin's.
Yeah.
And this is
Now she was in Washington. I think she's coming back this week and she'll be at BD Exocon. So I guess while you're in Japan.
Yeah.
Do you have meetings, the privilege to update it or?
Having compared to the other ones.
Yeah.
It is the, from what I've
Yeah, I
heard,
know, right?
the Orbitize
That's old stuff.
actively like making it better. And I've heard that these are not up to date, they're not taken care of.
Honestly,
So
I mean, I like.
and it's the one that it's the one that I'm using right now. So yeah, I actually haven't compared. It would be interesting to see how the other ones are. If they're like the way that Sarah and her team have made it is like very straightforward, like very, I don't know. Very easy to digest, I guess, and understand.
I tried this high clip to install that too. I don't have that, but I do have VIP. Which VIP is a little not so easy to install.
Yeah, seems like they are importing already test.
Oh, good. Yeah.
It's now it's big.
My complaint.
No.
Yeah.
I'm trying
It's the better version
set
of
up okay, so hopefully I should be able to participate. Okay.
Yeah, that would definitely make an error.
Neil, can I ask you some stupid questions? Like baby questions. I wanted and do other stuff first before these things.
Usually, if you just, instead of downloading things, you run a command through your terminal, it will download automatically. Like, isn't that how it works with Kitten? With your system?
You mean for installing Orbitize?
Yes.
So if you copy this thing.
Yeah, it will actually download things for you.
Yeah, so this is what I did for,
Pip install.
I did pip install for like VIP. And I just like opened the terminal, and as soon as I opened it, I just typed that in, and it installed.
But just to check, do you already have an Anaconda environment? Because that's, you don't want to do that until
Yeah, me too.
Anaconda is
And it'll like install it
because it will put it in some
somewhere
weird
else.
place. So I recommend Charlie. Just installing Anaconda first before you try doing it.
I'm one of these.
Be specialized.
I have no idea where I'm
Okay.
with that.
Yeah, so just Google
paper.
Yeah.
I did some research with Fortran back in undergrad.
I mean, I'm
It's just like, it's hilarious.
Right.
You can only have
But
like 7
it won't hurt to have a new one because it'll just have a fresh.
a punch card, a relic or whatever.
So yeah, just go right there. That'll take you to.
I just feel that.
Yeah, people who stay in Python to.
You are going to.
Yeah, I'm gonna be one of those. Where are my punch cards?
Oh, fun.
Probably I should put it actually on the computer, not in my Dropbox.
That would be okay.
I always put it in my home directory. Like
Yeah, download either of those.
So like Turnbull applications or something?
Because this is just the package installer. You can put it anywhere. It's just temporary, honestly.
Oh, yeah, the main download.
Thank you so much. So install Anaconda, then go to.
Then we'll go back to the specialized.
The one we want to install is the VIP thing, or?
That will be a good question. Yeah, that will be a good one to install. We actually don't have a working notebook right now.
Or, yeah. I thought Jonathan said he had it, or he still looks.
He had an older version. Yeah, I think the notebook doesn't work anymore. But
I mean,
we're,
that's kind of the issue that I'm running into.
yeah.
Like, Orbitize also just recently updated, so I'm like working last night and today, making it sure it's like I'm using the new one.
Right.
That is a really I'm trying to yeah. Bill and I'll be like, you know, I'll be confident that I know them enough that I can get like parts tomorrow. And then that's compatible. I don't know how much time it requires a higher order. So I can like 10 minutes. So I have to install both virtual.
It's a good question.
But it's
I have not.
literally
With you.
Yeah, probably.
I'd rather have
And
you.
there is a version of VIP. And I will works with only a single version. Yes. I think yeah. Anywhere from 5-10 minutes.
So I would say
Show the new like
today,
Yeah,
it should be good.
probably be doing more with the guy. I would be trying to get the dependencies of that one, and we'll deal with Radvel.
It sometimes
They're in a
gives
separate
some
environment tomorrow.
issues.
Right, okay. When I do install PHP, it gives me the error of Radvel, so I'm just wondering if any Radvel.
What is it?
It shouldn't depend on Radvel. So I would maybe, if it helps to uninstall Radvel for now,
Okay.
just to.
Oh, okay, try importing VIP.
I have all of them on
I would say it's changing. It's
different
changing
versions.
I see some changes.
In the installation.
So we only need what today? I can also
Okay,
honor.
so yeah, we're gonna need AstroPi.
But honestly, I think first thing I want is.
Sometimes change it around each version. And I might have to
You just have to mention that to the grid.
Okay, that'd be fine.
Yeah.
I think it's a big thing, like the glitch and how you.
Most important is
Yeah. Yeah.
It says
You have a problem with the organizer, right?
Yeah, although for now temporarily, I guess I have an
they're all like.
We'll see what happens.
How do you fix
On Windows. On Windows, it doesn't work.
Okay. I see. So you're on like a Sigma, or sorry, like a Linux emulator.
Yeah, I guess so. So
I didn't realize how loud it is. There's a lot of sirens, a lot of honking, and a lot of. Like, I mean, I woke up a couple of times. See, I'm like two dogs in this other building, but I also can hear as if they were right there. I've never used this before. But it's okay. I'm not in that room anymore. I'm in the 14 floor now. Maybe I'll make it better because I wasn't.
VIPs? Oh, it's been updated multiple times. Yeah, yeah, this is 2019. Oh, that's a different VIP. Yeah, look up Vortex image processing.
Actually, what I said.
So you said you installed, right?
So this is what I just emailed.
I said, no, this is a
Oh, wait, that might be a different one. Try VIP storage. That might be that one.
Oh, right, because you had almost a data challenge for that person, right?
It's like bad of the numbers, it's not how things. Yeah.
Sorry. You should tell booking about this. They might.
Yeah, it'll be very powerful. I mean,
And you can tell your credit card.
all of our known
And tell them.
targets are really easy for hires. There are hundreds of microarchitectures.
So
We need to make the Uber apply.
She was like, why didn't you call us? It's a manager.
Well, I'm also hoping is that
This and
Yeah, I just know that it was. Well, what
is that?
I don't remember what the numbers mean,
But
but
yeah,
yeah,
just
we should have the final
to
data.
deal with the.
I think we kind of see the higher rad goes on this guy, so.
The hotel is actually
Corner.
It's kind of funny because I've read a couple.
great, wow, but
Some of the people are actually kind of ready to say.
There's a lot of.
no, it's.
Because they've only given.
That's what I'm saying, like the upgraded is like the normal.
The errors.
Yeah, it's not
Yeah, I'm excited for what Troy and
Yeah, well, some
We
of
don't
them are
have a
psyched.
fridge, we don't have a blow dryer.
I mean, there was a fridge in my chili room.
Yeah, there was a fridge in
Disconnected,
mine.
so it was noisy.
Yeah, wow.
I had a fridge in my room.
But you still have time.
Baseline matters.
And I didn't have any plugs.
So impacts.
Maybe there's some attendance.
They're gonna level 1 data products, which is basically bits files and OS. They're not gonna, because
A hotel like this in the normal city should be
funding constraints WFIRST, they had to remove a full science center. Originally, I put it that
Yeah,
full,
in mine.
Yeah.
because it's like a full data processing pipeline.
Actually, though.
Giving it all to the science teams to be responsible.
So you have like AstroPi.
Then you're right in the center of Manhattan.
Well, no, it's not even,
From the fence.
it's not even
That's why they don't care.
between coasts, like no one is gonna get that.
Okay, so it depends on NumPy, SciPy, Matplotlib, Pandas. AstroPy, scikit-learn, scikit-image, GoToModes. Maybe you don't have scikit-learn an image.
Yeah, that's.
That will be
those
When they say free breakfast, you think it's
we'll have to make
I think you just.
One of the reasons why I'm a little bit behind is
By the way, if you want some coffee and snacks, it's already served.
It is, it's out there, yeah, 11.
We're going.
Okay, so
yeah,
I'll be back.
So we can.
Continue working on our installing
Yeah.
stuff, maybe get ready for the data challenge.
This week.
I know.
Oh, yeah. Yeah, and it was actually easier to code.
Yeah, this is high quality stuff. Dave is basically manifesting all of the things he's wanted to deliver us for a long, like just do it right.
So you realize how nice a working space could be.
It does a few things. It's kind of meant to be like a Swiss Army knife for high contrast data.
switch, and then you apply it.
Yeah, it's just a convenient example that we're showing people because it does source fitting, it's the relative astrometry. Yeah.
It's nice because it has windows and
It's about accessibility.
Yeah, that's what we're trying to do.
So I'm definitely,
I know.
NASA archive, you said the data's gonna be archived as results.
You can write on the walls.
The data is available to the public.
Yeah, so what I did was I uninstalled Radbo and then installed the.
I didn't even install that. VIP password was SciPy.
Okay.
So kind of like as I uninstalled it, so right now I understand.
Oh no. Okay. So I guess so Jupyter Notebook has a lot of APIs. And then it kind of should install it. Oh no. I feel if I installed Windows, but usually when some websites work fine, because it worked fine. I usually do the Python thing. It says to do like a Python things first, and then I do the Python alphabetize, and then it should work fine.
I have condos that you install.
Yeah, I'm all over it. See, that's so much work.
I used to.
Okay, so that's the one.
Yeah.
I should
The cover was available in CSI. We won't board it.
I'll send you the link to the.
But then it's
Because that's the one that has everything
the
in
solution
it.
to the problem of all the dependencies.
Like really nice documented.
I've been dealing with database.
You would have as a new pretend
That's been a whole different.
But also,
it's okay for me to stop.
yeah, I know. Because context is.
And install it in a condo.
They have excuse for you.
Okay, so even now you're gonna go for
There's a great proposal last week.
Oh, yeah, I
which
at some point, it was 3 hours in the So if you drive it more, your so it's like tiny letters, wide on that. So like that.
Oh, so you did like it and you installed it and everything?
It's the other way around, it's like the high school. So I couldn't look at it. I want that. You're so, it's like, it's like, that's right, you don't have a computer until you fix your library. It's like,
Oh, I don't know.
but
Do you have a final window?
Yeah, but you-
This one. Yeah, I I think that's the best one. The other one, I'm not even sure if it's the same.
TensorFlow,
I think it is, but like, this is more definitely.
Atom optimizer.
You use Atom.
I use Atom for GPUs, but it's on TensorFlow. So,
Use some kind of stochastic.
I can no, it's giving me another edge about.
I do post processing. Like all the data perspectives that it's in.
I didn't know.
I'm running Samba.
I'm going to try to see.
I'm already successfully installed VIP, but I cannot ignore it.
The Monte Carlo so damn slow, and so
Well, yeah, you haven't
waste so
successfully
much.
installed it until you have one thing.
Yeah,
Well, I can use it to get
Claim
the error
install
bar.
VIP, and then it's all green. I think it that means
It's okay.
ignore it, but still like.
This is like error bars.
Okay,
I don't need I don't use the error bars, so I don't know what restart. But it makes sense that if you want error bars.
Sometimes it has to
How
be
are you gonna do it?
Oh yeah, that's next.
No, it's like, no, like for example, like deep learning is not Bayesian. You just spit out an answer, you have no idea what's the error.
Yeah, exactly. So you have no idea what's going on.
So what we can do is, I'm going to train on half the data. So I have a time to
You know,
I'm going to sample every time.
I have another
I choose randomly, which
Yeah, you might want to.
could it be that
It's always
I'm not sure. I saw so much workshop.
Oh, yeah.
I'm actually not sure.
So you have
Okay,
an
so-
ensemble mean and an ensemble variance.
Thank you.
Sorry, you have an ensemble mean.
It doesn't matter that it's there.
I'm gonna
Actually, yeah,
randomly
that's
sample half.
that's good because then you can also use the app. You also have an app that you can just click. But
I think
Use all the data.
okay, so
What's the
we're
variance?
gonna have to add it to your.
I just restarted.
Try this. I'm gonna get my
So
notebook.
that is the default.
You don't get the variance on every single variance.
Sorry?
It looks
Yeah,
like
because then the
being
next-
non-genuine.
So are you in?
error bar for the transition.
Yeah.
And then the next
Okay,
chat is going to the trajectories that people use.
Oh,
Your
yeah.
error bars, so use the error bars. So it makes sense.
Oh, no.
I mean, yeah, but the thing is, like, it's harder.
Oh, okay, yeah, there's two people in there.
So we want to see a location.
You could get it.
Oh, background see it.
You get it by typing.
If you just enter a line that says
I
stop.
guess, I mean, because I've been running a lot of
File. Yeah. So that's.
There's a guy who.
Yeah, I did.
So then, yeah, you need to add in an anaconda.
I do.
This
I wanna check.
My mode is maximized.
where
Yeah,
instead of
apparently,
this, you
yeah.
put whatever anaconda.
File tree.
What is the error maximized?
Still giving you some.
I'm not.
But I'd probably say.
I think you write that back.
It looks like it's different.
It's actually a good question. So I don't have any issues, right? I think you do post processing is fine.
I think you're
I can find.
Well, I had a different one. Yeah, I know. It's like you don't want to update because you're working on this.
It doesn't have an.
And they kind of change things a bit.
No, you kind of. Show me
Nodes, machine, something.
Were you able to solve?
Measure.
Were you able to solve it? What's going on?
So
You want to be able to compare ADI. You want to have a variable measure.
I use
So what does this say now?
even if we restart the kernel and restart Spider and then
How well
so
WFIRST
so it's not the best, but like I use it when I'm like studying and then you can use as not just not specific or underneath the when I tried to
I'm gonna come back to you.
oh sure
Turns out, probably try a different command. So did you install with it?
Yeah.
Oh, you did?
Yeah, so I just added I just did
Okay.
That's something.
So then if you save that, it should
I restarted the Jupyter.
It's putting in a different environment, a different file tree. There's probably some shell
find it numbers
thing that I don't know how to
and
change.
figure out what's the maximum, like how many times the different templates like just randomly the number.
Does anyone else have and then you do source VIP?
But it was biased and
No.
just the maximum is higher than that.
Okay.
I think you're on
So hopefully that should work. So now if you type
So, what did you try to run? Just import it?
Okay, now it's the right one. Okay. So
Are you on
then
Python?
I'm writing
Are you on Python 3 or
notebook.
Python?
Like,
I think I'm on Python 3.
AP2 might be. Oh, you're on 3?
It's supposed to work on both. I have all kinds of
notebook.
But mine's
Space.
also
So maybe
older.
as long as you don't have that installed.
Maybe it's
Yay!
back
Okay,
to the
great.
past.
Yay, okay. Awesome. Yeah, that would be.
It kind of makes it hard of
Okay,
updating.
and
as
then
well,
you
because
can
there
also
are
just
actually
do
some
control C
concepts.
to like close it. Because you're not doing
Try importing
I can't access
SK
files on my computer.
Yeah, okay. And then I have Python working.
Okay.
Now the thing that we
So
have
I
to
guess,
do,
like,
now we install
Because
because that's the last step to like install things in the right.
This is not Unix, this is Windows.
That's how I can't
So,
remember.
do you know a user install Focus? Is there a way to tell the location of X people just by saying?
Maybe let me just Google this.
Yeah.
Yeah. Okay. Yeah.
Thanks,
Okay.
Alvaro.
We're trying a few things, but it's definitely putting it in the wrong.
Well, it's, I mean, it's.
Yeah, you have to do it for yours, right? So maybe it's
Yes. The first one. Yeah. I think the other one is if you have it, you want to upgrade. Okay. So I'm getting this. I'm already. Okay.
Yeah.
Okay, so now let's try installing orbitals. That would be the last step.
And VIP as well.
Oh, it's actually do that one first. That one's easier. So if you just copy that. Yeah.
Yeah, so I'm ready to do some.
Do you just Windows or?
I guess to try to.
Okay, yeah, mine's too.
But I know Kira basically.
The reason why we didn't want to install pip first before we didn't like finish setting up because it will like save the packages in your default Python once you get all version of Python, and then to get them into the new one and install pip. So it's better. Yay!
No, I do.
And so now for orbitizing.
Sure, it's not like.
Yeah, that's it.
Looks like sometimes we have PowerPoint based.
So let me.
Your image by using the errors, it's like within the one pixel.
Hopefully it's not, because it looks like
you're related to.
I know. I'm sure
I
it's
think
this.
so. Yeah, I think it's just and then you run this one and then the next one.
Yeah, he said he's actually using Python too.
Hopefully that works.
I don't know. I think
Yeah.
Some function passing.
I like. Yeah. So we're including.
So everything is.
Yeah,
Maybe
Raphael.
you have to implement maybe,
I'm not tempted.
Try it.
Yay! I think that's one of us to pass an argument.
Yeah.
Yeah.
So it's not something that came up.
Oh, I clicked on installation.
You know, I think I know what this is.
Yeah.
Okay. I was on my desktop and I actually had to change the code of VIP because I think it was I think it is a 2-year issue because I think that was
I'm not
the
sure, but I actually don't know.
Because 3.6 Aperture, I think they changed the name of this to vote utility.
So maybe just like didn't
And
have
then,
something
so I
to
had to
install
change
it.
like the code in VIP to agree with the new name.
Usually.
Okay, so I think let's be.
I can't tell you like.
Let me see your laptop.
So yeah,
I
that's.
can so.
I think I remember.
It had
It's definitely I don't have it here. Chili. Had a newer version of VIP.
So it says it's successfully installed, but maybe, hopefully not, but maybe if some, if you run something. Okay, it's not now, but at least now, most of the.
Oh, okay, so it's more like a PC.
I would imagine that I was
Okay, so.
We are mechanical now. We are not physics. We are engineers.
So it's Control C, right?
Like a check every time you like go to the US.
Of course. How do we go back home?
It actually, yeah, for me, because it makes more sense with this computer, but I didn't have a Mac at work, so.
Or even worse case.
Other ways. It might update a lot quicker.
I think what the issue might be, because I remember I had a newer version in my piece in my computer as well, and I had to actually change some of the code in VIP to agree with like some newer vote utils version, I think, or something. Yeah. Because I think I might have had the same issue that she's having.
For the purpose of the demo.
Well, it was like for Radball, you need to have tech.
Yeah, we're figuring out this.
The first time I used it, I tested one day and one night. Specific TensorFlow just makes it DCUT and then
It's a separate thing.
Okay, yeah.
Well, that's one way, I guess. I think I know why it was broken though.
So that's a good
Or maybe.
Yeah.
On the internet, how to check.
That's what I'm doing right now.
But in the
I remember it was.
Yeah, we're trying to see what's favorite on
I remember having to change some like X's to like circle X's, like I think it was like defining an aperture, and I think the new boat utils changed like the circle X or something, and it just broke them. Yeah.
Okay, yeah, so.
Mine is actually.
Not really.
Okay. What we can do,
or maybe an older boat utils would work. I don't know how.
That'd be right.
do you want to make?
Yeah. But actually, that's actually
Everyone else.
Yeah.
VIP.
trying.
Oh, okay.
So we transfer.
So
I
you.
don't understand some argument.
So I'm going to combine.
Can I see your error? I mean, I've installed it. It's actually an older one.
And that only
I
requires.
remember having to actually change some of the VIP code to fix, but.
Yeah, this is the error.
Okay. So it's not importing, right?
Yeah, it can.
Yeah, this aperture, I think
It does. It's
I'm just curious. Let me try changing it on your.
So what?
I think it is the same error.
Just printed the version I'm using. I think that was the trick.
Yes,
The installation of another.
Okay. Let me just see something real quick with your.
Okay, so that might be the recipe that everyone
do it.
Yeah, except I thought I had taken notes of that installation.
Were you able to latex up QY? I don't know if that's. I think that's a cheap version. So Python, I'm 3.2.8, and yeah, I think most people.
No, yeah, I think that's
Oh, yeah.
So
No, I
I think I made this.
Right, I mean, so you mean
but I remember.
But how can I
So
switch?
I think.
or maybe they haven't tried to import it yet. Maybe.
We may have to try and install
We have to underscore NCI. I don't need that.
You can try that.
Which,
Yeah.
Python?
After.
Are you still downloading?
Yeah, that seems like a good idea.
So.
It could be, yeah.
Like things hey, let me stop it so we can at least test it with you then. I'll wait for mine. So then that's it. I just didn't find out. Let me tell you a bit. If that works.
You not have data for direct imaging.
If this, okay, no. I think I think that's what I did, but I can't guarantee it.
No, it's okay.
There's a hard line in this room. For internet, because you're trying to download these giant packages, stupid tech package. is what's making
Oh,
it
okay,
difficult.
So we're
Which one?
The you need tech to run Radwell.
Oh, sorry, you're not.
Tech, LaTeX.
So, just because of the
Brad Bell is honestly not, for today, it won't be that.
Yeah.
Yeah, I had like
So
a
did you get
But
the
now
Astro file?
it's taking 40 minutes to download it. But just
We got the
because
Anaconda and the Python and the pip. So she got,
I used to work.
oh, I get, is that?
Work on the install Astro.
Okay.
I just use.
That's,
But
I
we
would,
installed Organize and we installed,
I'm kind of
actually.
so,
I should
And it's in
probably
the
know,
right,
but I'm
it's,
kind of
when you say which Python it is.
yeah, okay, so that's good.
yeah, yeah, that is.
Yeah,
I
something
think
after which.
very
still don't know what it is. I'm excited. Actually, what do you think of this error message? It says that when I installed
Then I should believe you.
the Ragdoll, when I
I think my computer doesn't follow the best practices. I have a hot button
I've seen a few people have seen weird messages about the corner package dependency. I'm not really sure what's the name of it. I think that actually Julian might have a recipe for installing the IP that's different from the standard way. So we can play that on the background, right?
You can try to do another environment.
This was for Ragdoll.
Oh, that was, sorry, Ragdoll. That's different.
VIP installed this.
No problem.
Yeah, but
You run it?
yeah, what should I do?
So
What should I do?
open, if you open your notebook,
Some of it is also done called Q observing.
no, that's okay. And so you choose your directory and then you can open a notebook and wherever you want to save it.
A sheet. Instructions about what to do.
You want to make a, you can also make a folder specifically for that if you want to name it like, I don't know.
It's fine. We'll,
Yes. Yeah, that's it. It's like a finder window.
I want to add a
You can either do, yeah,
that's fine. So that's a problem. People, as long as people know.
so I think you
Yeah,
can
but it's not
So we should try to move on, right? So here's my.
Just connect your computer
Yeah,
I mean, there are some documents here, I think.
Oh, they have the interval.
I'm about to run Ragdoll.
Yeah, so, you know, and get other people data, yeah. But you have to know what's going on. So my first students had to reduce data. Then I'll tell them.
Yeah. Is it just not? Or is it?
I'm like super.
No, neither did I. My hair was like this.
So then you do new. And I don't break. Like, so now you can import.
Okay, we're gonna move on.
Doesn't tell you what was.
Yeah.
Everyone is.
We're gonna have someone present. So we're gonna move on to the first basic notebook, which are we don't require any package like VIP or Radvel or Orbitize, but just AstroPy and AstroComba. So Neil is going to show that basically how to read the data and how to do basic DSF subtraction, and also how to look at parallax and proper motion. I don't know if we do all of that now.
Yeah, so
yes,
that's right. The box folder. So follow a link to the box directory that was in the Slack, right?
Yeah, so box should be open for download to anyone with the link.
Right.
I think.
Did you put it on the Slack page?
Yeah, put it on the,
Yes, I think I did.
I think it's
yeah, I don't see it yet.
Maybe I didn't then. Okay.
You just search new URL from Julian.
I'm in W searching.
Slack or?
Okay, I just put it now. Okay. This is the box folder.
Great.
Can you?
Notebooks,
There you go.
that's the one.
Yeah, so download inside the notebooks folder. There are 2 Python notebooks. And you can probably just download the whole directory. If you click on the more options part, you can just do
Is everything we need in the notebook? Or are there any files that you? Sorry.
Yes, good. Thanks for reminding me.
Oh, okay.
There's a folder called data.
Okay, thank you.
No, but how did you copy the data there?
It's there. It's there. So
Okay.
thank you. Download that folder as well,
So it's in.
which has some image files, some FITS files, and a Microsoft spreadsheet. And for people who are having trouble with their Python installation, I know you may not be able to follow along and run the notebook, but if you can at least open the images with SAO image or whatever FITS file viewer you have, that might be a start at least.
Starting with the editor.
Yeah, that will be the first one. Yeah. Or you can look on over the shoulder of your neighbor who has a working AstroPi installation. And, that should be.
Yeah, you should somebody into your computer.
So I can have the link on the file. Just open it directly.
So Neil, is Box just your guys' version of Dropbox?
Yes. Yeah, if you set it up, you can have it
Oh, it did it. Okay.
synced if you want.
Oh, yeah.
So does everyone have the files from Box now downloaded? Good. So I'll just flip through a few charts that were covering things that weren't in Julian's presentation. So we already got a preview of what the data look like. The coronagraph has a very small field of view for, the context of astronomy. We see an annular radius around the star, half an arc second in radius. That's what we call the outer working angle of the coronagraph. So it's a very narrow field of view, but that's okay because planets are close to stars. So we're not trying to see the whole sky at once. And we also call the inner part, where we don't get any more useful data, the inner working angle of the coronagraph. So we have that jargon, IWA, OWA, for coronagraphs, telling us what are the actual angular separations where we have useful data. All the simulations that we're showing are with this one specific coronagraph design called the hybrid LEO coronagraph. It's actually been demonstrated in the lab at JPL with lots of that's with laser sources acting as starlight with the full control loops, correcting and digging what we call this dark hole around the star, which depends on this active optics, kind of like adaptive optics for ground telescopes to control the residual starlight and make sure we have the deepest possible contrast and sensitivity. This is a simulation. So the images that we're using are not based on lab data, they're based on numerical simulations of the observatory. Note about the point spread function. So in astronomy, another piece of jargon is the PSF. PSF stands for point spread function. So that's the response of the telescope and instrument combined to a point source on the sky. So it's an unresolved distant object that has an effectively infinite distance. So we don't resolve any spatial information on that source, but you wind up with a diffraction pattern. In classical optics, it's the Airy disk, the Airy function. If it's a perfectly circular telescope pupil, for us, we have a weird, funky telescope pupil that changes the shape of that diffraction pattern. But this profile nevertheless resembles an Airy disk, and you have this bright central lobe, and then a ring around it where some other fraction of the energy goes. And the pixel scale is fixed, so that's the same as what we think will be the final design, about 20 milliarc seconds across each detector pixel. And for reference, most of the planets that we detect are going to be of order 100 to a few hundred milliarc seconds away from their stars. And so this right-hand plot is a way to visualize, when we look at the chronograph data, the amount of light that actually gets transmitted from the sky. So a point source here compared to a point source there, you don't get the same amount of light, right? Because the chronograph has an occulting mask that suppresses light that's close to the center of the image. And so the idea is to perfectly cancel out the star. So right in the middle, we have effectively zero transmission, right, from the sky. But if we're at a certain angle, again, that term, the inner working angle, where we actually have a decent amount of energy coming through the instrument, that's where we're going to be searching for sources. And this map is one of the calibration files that we provide along with the simulated data. So you have knowledge of where the useful measurements are in the image. Another note is that what we call astrometry, that's measuring the position of a planet source in the image. And to fit the orbit of some planet that we discover, we're going to need to measure very precisely the two-dimensional projected separation of that planet from the star over the course of several years. And there are distortions in that, because when we look at planets that are very close to their star, the PSF, as we'll see in the tutorial notebook, gets distorted when we're right on the mask. That can bias your position that you try to infer for a planet, because light is getting hidden behind the mask just to the left of the source. And so you're effectively biasing the centroid that you try to measure is effectively biased away from the mask. So it's something to keep in mind when we're doing astrometry and trying to fit the orbit of some planets that we find. Julian already showed an important nuance of imaging planets in reflected starlight as opposed to the infrared imaging, is that the amount of light that gets reflected back to us actually varies with the orbital phase of the planet. So we have, almost like the moon, the planet goes through phases over its orbit. And so if you wait a few years, the planet might disappear, not because it's behind necessarily the inner working angle, but because you're observing it in like a new moon phase. When it gets, the phase curve goes dark. And so when you don't have prior knowledge of the orbit, there will be some ambiguity in whether a planet is disappearing because of where it is in its orbit track, or whether it's lost behind the coronagraph for some reason. And also the effect of the coronagraph mask itself. So remember on that plot where we showed the transmission map, you can have effects where if the separation of the planet from the star is changing over time, changing over the orbit, you can tell that at these edges, it's at just a slightly larger angular separation from the star, the planet gets brighter, not because of the phase, but because of the fact that the attenuation from the mask is lower, because it's at a slightly higher angle at this point than it is over here. So you have some combined effects that are hard to disentangle without loss of follow-up time. And I think that's the last. Oh yeah, one more thing I wanted to show. To be realistic with our images, we're including simulations of the exozodiacal light in those systems. And I would break it down into two impacts that this has on the data. First is that if you have some cloud of dust around the star, there's a heavy dependence in how much light is getting scattered back to you based on how far away you're looking to the star. So there's an roughly R-squared dependence in how much scattered light is coming back to you. So most of the contribution is coming really close to the star. And so it has the effect of this cusp that's actually concentrated near the star. The effect of that is not so much an actual obvious structure, like you don't necessarily see an extended source like this, but that concentration of light there is effectively making the star fatter and making diffracted light appear around the image. So you wind up creating almost diffraction structures due to the fact that you have scattered light coming at small angles from the star. That's one effect. However, if the optical density of the debris is high enough, as Janelli knows, you will actually see resolved extended emission inside the field of view. And that's what we're simulating here, is we've actually taken a dynamical model of a debris disk from Chris Sark, where we're incorporating the effects of the planet's gravity on the debris, and you wind up with these interesting resonant structures that are actually going to revolve around the star along with the planet. And so this is the intensity distribution of that debris disk on the sky when we put it through our instrument model, and we have this blurred out because we have a finite resolution from the point spread function. You wind up with, the shadow caused by the occulting mask, attenuating light in the center, but then you have this ring-like feature where you're getting bright enough emission in that diffuse part poking out from behind the occulting mask. And so the impact of some of these debris features will be some of the most difficult things to contend with and separate from planet point sources. And I'll stop there and jump right into this notebook. So we're going to open the one called HLC Data Tour. It's a little bigger.
It should be in your notebooks.
Down, or you want to put it there?
So if you've never used Jupyter before, I should have said that we're going to want to go to
Yeah. Oh, yeah, okay, good. So then now you should be able to go into so if you this, if you go to where the so maybe
So if you've never opened a notebook before, this is the command you want to use from your terminal to open that file. Jupyter-notebook. Everyone got that part?
so if you want to close it, where did you
Okay, so I assume everyone who's got the notebook open can see in their web browser this kind of screen, right? Good. So first steps are we're just loading the dependencies. The first thing you're going to want to change is where we say the file path to the images. So there are two directories that you want to keep track of. There's the data directory and the calibration directory. So the data directory has the image fits files, and the calibration folder has some of the calibration products that will be needed to interpret the data. You're going to want to change those two paths to whatever location you downloaded them on your machine is. Right.
Yeah.
And a way to check if you run the next two cells using the OS list dir command is just going to show you all the files that are inside those directories. So everyone has the file path set and they see all the files inside those with the list command. So the next cell is just loading those FITS files. So we're going to load, because there are, I found a typo. So in the fourth command here, where it's loading it, it should be 4, not 3. So there are 4 epochs of images in the simulation. So switch that number. And we have 4 images of the science star and 4 images for the reference star. And the reason we look at reference star, as Julian said, is that it allows us to get an independent measure of the speckle noise that gives us a way to track those speckles from the image. That's one possible way to deal with the speckle noise that is a source of confusion with planet point sources. So is everyone able to load their FITS files with that? Okay, so during the observing sequence, the spacecraft actually switches between 2 roll angles. They're 26 degrees apart. So the way we've organized those images, the first dimension of the data array is the roll index. So changing that index between 0 and 1 is going to set which roll state you're looking at the coad in. And we'll see in a little bit how that actually looks. But the important thing is to know that that first dimension is what sets the role you're looking at. The reference star, on the other hand, is only observed in one roll state because there's no astrophysical sources of interest in the reference star, we hope. We don't use two rolls for that one. So it's a simple two-dimensional array in that case. So there's just a way of actually recovering what the roll angles are in the data. They're encoded in one of the header parameters or extensions. And we can also look at the header of the science fits file is going to tell you things like what the integration time of the coad is, what the pixel scale is, both in units of arc seconds, lambda over d, which is used to describe the diffraction scale of the image, the wavelength bandpass, and things about the star from catalogs like the magnitude and the proper motion and parallax, all there. Yeah.
Can you convert this into front count? Is there any way?
No, because these have already been co-added.
So I guess like how to translate the numbers that you get from the image into the actual photons?
Oh, right. So good question. You can assume a certain quantum efficiency, 0.75, which is a good approximation for how, the translation between the photoelectrons incident in each pixel and the photons that were incident on that array. Does that make sense?
So the images are in electrons?
They're in photoelectrons, yeah. So they've already had the detector quantum efficiency applied to them. And by the way, that reminds me also, we're assuming that you don't have to do any dark subtraction, any bias subtraction, or flat fielding. That's already taken care of. So you have calibrated images that are in units of photoelectrons, summed photoelectrons over the whole integration. Okay, because these are, if you get to the next cell, we're actually going to see what these images look like. These are the raw coads. And you can see, mostly we have this residual starlight around the field of view. There's nothing obvious there. Maybe that pokes out at you, but nothing really dramatic, right? Mostly just speckle noise. And so this is giving you, the scale of the image. So in our brightest pixel, we've collected 400 photoelectrons over the course of that whole, something like 30-hour integration. So now the next part is where it gets interesting, where we actually try just doing a simple roll subtraction. So if you run the next cells to hopefully produce these images for you. All we've done here is we've taken roll 2 and subtracted it from roll 1, and the right-hand side we've done the opposite, right? And so there you're seeing the effect of, because the sky has rotated 26 degrees between those two observations, that any source that's actually on the sky is going to appear at different angles. And you wind up with this positive, negative residual because in one hand, you're subtracting an image that has the same source in it at a different angle. So the next part in...
Why there is in left picture, at 20 coordinate on x-axis, there is a bright pixel. It doesn't show up in...
Show dark.
Yeah, so this thing, right? Yeah. So that's really just an artifact of the fact that the coronagraph had worse residual starlight in one of the roll states than the other one. So there's time varying errors in these simulations that are meant to be, realistic. So we'll expect in some times or some roll states, you'll have worse speckle noise than in other times. Then we're gonna combine these, right? So how do we actually combine those two images and do something useful? Is we have to rotate one of them into the other frame, right? So in this case, we're using a built-in rotation interpolation in an SK image library. People might need to install that.
Yeah, I actually got an error. I wanted to see if anyone else was getting it. It's saying cannot import name, validate length, something.
Yeah, I'm gonna.
Okay. Yeah, it's not. Yeah. Okay. And I have the package, but it's giving me this error. First frame
What's that?
with mine. Yeah, it's giving me this
Oh,
error.
really?
And I just got it too. So I'm not sure. Oh, no, I hope not. I think it may be updating a package, maybe.
Right. So maybe try.
Maybe it's updating NumPy.
Try. Maybe do a conda update SK image. See if it will.
Maybe I just need to update my bits.
Conda.
So how many people got an error trying to run the SK image rotate? Okay.
The first one, the first plot.
Conda SK image
Oh,
update.
okay. Yeah, so do conda update SK image. Let's see what happens.
Like that.
Yeah, mine worked.
I'd be interested what works to fix it so the people who had that problem to find a way to. So do conda install SK image.
It's okay.
Oh, you need help?
Interesting.
So installing SK imagery now.
Oh, it needs SK.
I thought I had it. I'm pretty sure I had it installed, but maybe.
Yeah, so now
That's
try like restart on all.
All right. Start the kernel. Right. Since it's taken something from before, probably. We'll just run it.
Yeah.
Didn't fix it.
Lengths. Okay.
Okay, so we'll move on. I guess we'll go back to that later. But
Does that anything else in the notebook use that refer to the D rotate?
no.
Okay.
Yeah, so
Then I should be able to run the rest.
I think so, yeah. Yeah, it must be some kind of version issue. So we'll go back to that and try to get that working later on. So put down a question to just get people thinking and talking about this. So let's say you've done the subtraction and you have a point source. There's no perfect answers to this, but how would you estimate the signal to noise ratio of that source?
Mean by study.
What?
Measure the mean and divide by the standard deviation.
The mean of what?
Pixels.
Or of apertures going around, like at an annulus.
Like a small.
Yeah, so remind me your name again?
Blake.
Blake, so you're saying we could take some circles,
at the same
apertures that are
radius.
like the same size as the point source, and use those as like ways to sample the noise at different points in the image. That's a cool way to do this. Any other?
You're asking for signal to noise or significance of detection?
Not significance of detection, because that would be a harder question. Just the signal to noise.
Can calculate the Fourier power spectrum divided by the noise spectrum and integrate that overall.
So you would take, would that give you a clean way to separate the point source, you think?
I don't see why not, because you know, if you know the noise spectrum, you can separate out the scale of the signal and everything else will be into
So I've never done it that way, but it sounds like a good idea to try.
I'm sorry, say that again?
It's probably very slow in 2D though.
Can you repeat a bit louder for the
You can take Fourier
Fourier, yeah.
and then calculate the power spectrum and then divide that by the noise spectrum and integrate that ratio over all frequency. And so your signal on the scale of that will give a peak and everything else will be 1. So that gives you a ratio of.
So I'd be really interested later on today when we have some free hacking time, is we compare 2 different ways to measure the SNR and see how they agree or disagree.
Is that what you would call a noise map? Maybe. I think I've heard people call that noise.
You can do a noise map with whichever method you're using to calculate the noise, but
Oh, okay, I see.
after his method, after
Like a signal to
standard
noise.
deviation or whatever, you can do a noise map. And you usually do it on some apertures of, couple full width half max or something.
Yeah, so the classical way to measure SNR is what we propose, where we take some kind of circular aperture that we think approximates where most of the energy from the point source is. We take the sum of those pixels, and then we compare samples around the image that hopefully are affected by the same random errors, and take their standard deviation.
Like sigma clipping?
Well, that would be a way to decide, is that, a confident detection?
So by knowing the diffraction limiter size of the planet, and you can make the aperture of the size and then search for,
Yeah, you can do cross correlation between your point spread model. So move on. So that was one demonstration of one of the subtraction methods. The other one is reference differential imaging. So this one I can tell you is not going to be as clean because I'm doing a very crude version of reference differential imaging, or RDI, where I'm not really doing a careful job of scaling the reference before I subtract it from the science image. So if we go back to the raw images, we have our coads here, right? And because these are different stars, they have very different fluxes, right? So in general, the reference star is going to be much brighter. In this case, it's a 2nd magnitude star versus our 5th magnitude star for our science target. So we get a lot more counts in that reference image. That means we have to scale it in a careful way before we try to subtract it from the science image. I did a really crude ratio here where I just took the sum of the counts in the reference coad versus the science coad, and I used that to scale the reference image. So I get about a factor of 5 in ratio total counts between the science and reference star. And if I do that, I'm going to get this. And by the way, I chose a different epoch. That's why it's not in the same place. It's moved, orbited the star over 2 years. And so
you can tell that it's not too hard to actually see something. Right? There's no post-processing whatsoever.
Yeah, no fancy clip or Loki here. And the fact is that because with CGI, we have an active control system and a very stable PSF, really simple subtraction will get you 90% of the way to your final image. So it's
well done.
It's somehow it's been our experience in our last tutorial, the hardcore post-processing experts spent hours and hours perfecting their clip implementation, but actually you don't really need it if you just want to say, okay, where are my candidates? You know, that will help you.
You may want to use it after, and once you already did, let's say, maybe almost the full challenge on like an easy detection like this, you might want to do post-processing to see if there's something else or whatever, you know. But, you don't really need it for maybe 80% of the challenges.
Yeah. Oh yeah, second group question. How would we improve the subtraction? I kind of answered it, or at least partially answered it, but I'm curious to hear your ideas for how we could do a better version of this, even this simple subtraction. How would you improve that?
Using the reference star?
Yeah, just doing this reference subtraction. How would we get a better, do you think a cleaner residual in compared to what we did with the scaling factor? Yoni knows.
I don't know that I know, but like, are we limited to just perfectly centered sources and stuff? Like, because there's some cool stuff you can do, like in the James Webb documentation, where they talk about like dithering.
Yeah, that's a great idea. It's a good way to deal with detector calibration
I
errors.
was wondering whether you can just sort of use that to, like, even if you have good detector strength, like you could just sort of artificially getting better results. But yeah, you have to spend a lot more time on that.
The reason it's done, I mean, the reason we implemented this for James Webb is because the centering is not actually very reliable from a science target to a reference star. So we decided to move around reference star so you have diversity and more chance to actually have a good subtraction. But here on WFIRST, you can assume that they are really well centered, because otherwise the whole photon counting thing doesn't work. You know, you just blow the whole thing.
Yeah.
If the star would move a little bit, and you see it in the little video I showed, you know, every time you go back from the reference star and so on, you see a bit of a bright thing. And that's really a tiny jitter, you know. So imagine you have a bigger jitter. So in the case of WFIRST, I mean, I don't think we need that, and I don't think we were going to do that, right? Maybe I'm wrong. But
right. There's no like planned dithering, and I should have said in the beginning that we've already centered the image perfectly, so you don't have to worry about recentering it.
And you have this wavefront control loop that always maintains, you know, the star perfectly behind the mask. So I think, you know, the question was simpler. Is you just want a better scaling, right? So
like rotate and differentiate.
So one way to do a better scaling is to minimize probably the residual of your subtraction instead of you know, trying 5, 5.1, 4.9. You know, you just minimize or something like that. I don't know what you were going to say.
Yeah, that's
what Loki does a little.
Yeah, so you could almost by the brute force optimization find the scaling factor that gives you the lowest starlight residual. Another tip from my experience is that you really want to mask off the parts of the data where you don't think you're going to actually search for things, because you're going to have bigger variances, certainly in the center of the image over time, that are just going to mess up the ratio. So I think in my experience, you would get a better simple subtraction if you actually had maxed off the center before you measured the ratio. So if you only summed the total counts in a dark annulus as opposed to the bright central part, I think you would get a better result. But I'd be interested to see.
So reference star and the sign star, they don't rotate?
Right, these are, in this case, no matter how you rotate the telescope, the speckle pattern is always going to have the same orientation because that's fixed in the instrument geometry. So the sky is what rotates between the different roll states. So it's almost irrelevant what the roll angle was during the reference star observation. So in that case, the subtraction is direct. There's no rotation applied to the reference before we subtract it from the science image.
Unless you have exozodi on the...
That way. Yeah, if you have astrophysical things going on in your reference star, then you have other problems.
Turns out Vega is not so.
Yeah. Yeah. So part of the task of preparing for CGI is actually reconnaissance of our so-called reference stars to make sure they're actually clean, perfect point sources, that we're not going to have too many surprises.
And by reconnaissance, you mean ground-based imaging?
Yes.
Or
You've been doing tech and clear cam to look at some of these targets, stars.
are you guys going to make that data public?
That's
Never know, someone's trash might be someone else's treasure.
yeah, and part of that is there's only, just given the field of view available, there's only a few stars that it's really that helpful for, but that'll be finished. I think the final observations for that are in January, and then after that, there's a target that actually in Hubble time before, like and orbit. Yeah. Yeah.
I would also do like in the Fourier plane, like take the Fourier transform of each image and then subtract there in the Fourier plane. So there you can easily differentiate all noise will go to one spatial frequency. The image will go into one spatial frequency, and I think you have another different view in the Fourier plane than direct image plane.
Yeah, it's worth thinking about. I mean, I know that some people who analyze adaptive optics images do high pass filters in the Fourier domain before they even try to do too much. So there are different. It's worth trying that. It is difficult though. The more you do in the Fourier domain, you might have a harder time recovering estimates of the source properties. So you always have to do a lot of legwork to make sure you know what it's doing to your systematics and everything.
Once you clean in the Fourier plane, you can reverse back inverse Fourier transform. Then you get back the image plane.
Yeah, that's right.
I mean, I'm saying that like in the Fourier plane, you can clean all the noise and you can come back the image plane and you can see the exoplanet. I don't know. It's an idea.
Yeah, no, it's worth trying. See that. So we don't have too much time. I think, when is our lunch break? Is it already?
It says 12:30.
Okay, so we have 8 minutes. Just going to quickly run through these calibration products that we're giving to you alongside the image simulations. So one of the files is called Sci-Star Unocculted PSF model. And that is a way to understand how to convert the flux you see of a point source in your data to actual contrast or flux ratio units, right? So this is a way of saying, given the count rate I'm seeing from this source, is that a 10⁷ ratio in contrast, or is it 10⁹? to know that, you have to have some calibration knowledge of how bright the star is. And so we provide this model that's basically saying, if we took away the occulting mask of the HLC and we just stared at the science target, what would be our photon arrival rate on the detector? And so that's what this image is giving you. So it's giving us, in units of count rates per second, photons per second. So to actually make use of this to interpret point sources in your image, you would need to apply the QE, this 0.75 detector QE, and you also need to think of, well, what was actually my integration time, because this is an arrival photons per second, so you'd have to multiply this by the integration time to get how much starlight would come in each pixel. Okay, so then onto the point source off-axis or planet point source model. We have these two files. These are generated by John Christ, who is one of the experts in simulating the coronagraph at JPL. These are also publicly available on the IPAC website, but they give you a way to see how the PSF is distorted as it moves around the image. So a planet that's at different points in the image is going to have different effects to its point spread function. And the main effect is attenuation, right? As we get close to the center of the image, we have the occulting mask that's attenuating the light going through. That's the biggest effect. But there's also, there's the map again of the transmission and the cross section, how that looks.
Question.
Yeah.
If the PSF shape gets distorted across the image, is that also true for the astrometry? Is there an astrometric distortion model that we have access to?
There's no ready-made distortion model, so it's we can provide maybe plots that John Christ has made of this, but we don't have. It's up to the participants to correct that distortion. Yeah. So in this example, let me know if I'm moving too quickly, but I just want to show, just compare again how that point source looks when we're comparing two separations. So we often talk about separations in lambda over d, because these are kind of like the natural units of the coronagraph. It gives us the angular scale of the diffraction from the instrument. And we know, we're dealing with very small separations, and the outer working angle of the HLC is 9 lambda over d. So you can think of that as, the outer edge of that image. We have close to the star, you can see we're getting that close to the occulting mass. We're getting, a change in the morphology of the PSF. And so there's an open question. We can talk about it later maybe. How would you actually go about correcting that if you measured a planet at some separation? Because since I'm moving quickly since our lunch is coming up.
Yeah.
Okay, so we'll go on to the next part.
We should return to that though, because it seems hard.
It is.
So.
It is hard.
Well, I mean, some packages have a way to basically say, this is the PSF at the location that I'm interested in. Mm-hmm. And then use that PSF to basically forward model. So meaning using that precise shape to retrieve the photometry and astrometry instead of choosing Gaussian.
We do have these two maps, right? These two PSFs for the different separations.
We have
That's right.
More than two, right?
There's many. So there's a whole.
There's more than two.
There's a whole cube of John Christ's models.
Okay.
All these separations.
Interpolate offset versus location, and then extrapolate to your location of your other point sources.
Yeah, so we provide the information that you would need to do this correction, but we're not necessarily giving you a ready-made.
I mean, let's say this kind of correction would bring you further and give you better results, but you don't need it at the order 0 of the data challenge, I would say.
Yeah, your orbit fit will converge without doing this correction, but it's just getting the extra level of accuracy that will help this.
This is just to be as realistic as possible, and eventually also discriminate participants, you know, who took what into account. You know.
Well, it's really useful to go through all these things, just, or I should say it's really educational, just to sort of see all the little.
And the last part, I was just making the point in this last cell. These PSF models are normalized in a very specific way because the throughput of the instrument is an important effect in interpreting the data. The way John Chris does this, which I think makes sense, is he says how much light, how much energy was landing on the primary mirror, given the pupil shape and the telescope aperture and all the obscurations and the spider, and that's the denominator. And the numerator, which is each pixel in that model, is how much energy gets to the image plane after propagating through the coronagraph. So this is a specific normalization that allows us to say how much energy from a point source actually gets through the coronagraph. So if we go, I'm summing up the entire image just to give an example. So that's 6 lambda over d PSF. If we add up all the energy in that image, you wind up with 12%. So the coronagraph mask just by itself, I'm not including the mirror reflectivity and filter transmission losses, just the coronagraph mask itself is removing a lot of energy. So we have to deal with the fact that fundamentally the coronagraph game is about these trade spaces where we have to actually throw out light, which we wish we had in order to get good starlight suppression. So this is the balance that the team at JPL has spent years finding the right balance between throughput and performance. You know, and an open question there, which we can talk about later also, is, well, that's the whole image. That's not actually all useful, right? Because all this stuff out here, really faint diffraction structure is not going to show up from a planet. You're only going to get the very central core of the PSF. So that's a different throughput number. And you would have to do a different calculation to say how much goes just to the core. Yeah.
So you give us the PSF without the coronagraph, it's just for us to calculate the throughput?
This model?
Previously, before you talk about the PSF library with different separation, you mentioned one PSF that is all-coded star PSF. I'm not sure why you gave us that.
Right. So this is really serving the purpose of converting between counts in the image and contrast or flux ratio. So if you detected a point source in the image, you want to know what the flux ratio is relative to the star. This count rate is specific to our target star that we're looking at. So this is actual, as if we had a perfect image of the star and observed without the coronagraph mask in the way. So that gives you a way to compare the count rate in a planet PSF. Taking their ratio is how you get the flux ratio between the planets.
So this is, here you remove just the focal plane mask, right?
That's right, yeah.
You don't remove, so everything else like the Leo star, all the stuff that is attenuating is still there.
can you give me a very simple example? For example, if the planet counts is 1 and this is 10, what is the result?
Depends where your planet is. So this is equivalent to putting the star like super far away, I guess.
That's right.
But
yeah.
we don't do it because the field of view is so small. We can't do that.
But if we make your example simple, so let's say the planet is at 6 lambda over d from the star, then you have pretty much full transmission of the PSF. Then that ratio is 10. But to get that number right, you would have to know the integration time of your specific image, right? Because there's a certain number of seconds that went into measuring that one that you said. So if you've already converted that to photons per second, then that flux ratio is 10.
So on the transmission curve, here you would basically be completely at the flat part, at 1.
Yeah. But it's a good idea. We should try to provide a specific example of how that calculation is done. So there's a subtlety to that.
Any questions? So, I mean, Neil showed pretty advanced stuff, but again, this is what you have to deal with if you want to get really precise things, I would say. But there is also, I mean, the beginning was actually very pretty basic on how to retrieve one point source, right?
Like, this isn't exactly the behavior of the Leo photograph. This is what we're measuring.
Okay, so a hint for the people paying attention that not every point source necessarily orbiting the star we look at, because there are background stars, right? We're looking at a relatively nearby star in the galaxy, but behind there is an entire galaxy, right, of faint M dwarfs that could be 26th, 28th magnitude in brightness that we have no idea knowing in advance whether they're in the same image or not. So how do we deal with that? Fortunately, it's not a new problem, right? So astronomers who are doing ground-based adaptive optics surveys for things like brown dwarfs and young gas giants use astrometry to discriminate background stars from real physically bound objects. And so one of the things is the parallax motion, just due to the fact that we're going around the sun, and the apparent angle of any star that's at a very great distance relative to our nearby star is going to change. So the nearby star, which could be, in our case, we're using 47 UMA as our simulation target. It's about 14 parsecs away. So it has, over the course of 1 year, as Earth orbits the sun, there's a parallax motion, something like 70 milliarc seconds. And so it's a big enough angle that if you look at how 47 UMA moves against background stars, you can easily measure that with an instrument like CGI. Not just parallax, but what also matters is the proper motion of the star. That's just the relative velocity of whatever target star we're looking at. And we have already very good measurements of what the proper motion and parallax of our targets are, because the Gaia satellite is measuring these to spectacular precision now for all the nearby stars. So we know the proper motion and parallax of 47 UMA very well, and we can use that combined with our knowledge of the actual observing dates of our images to predict what, if there's a background star in an image, how would it move? And so these are just examples from the literature. There are probably like dozens of these from adaptive optics observers who have discovered faint high contrast companions, and they followed up with a bunch of data points, and they said, okay, how do we know this thing is physically bound to the star? Well, you know, based on your knowledge of the proper motion and parallax, that the background, if it were a background star, it would have gone here and there instead of staying in some neighborhood near the star. And similarly, this is just a more recent example of the same thing. Again, they're showing if it were a background object, it would have done this, but instead it did this. So that gives us a lot higher confidence that it's actually orbiting the star in our image. So the next tutorial notebook is just meant to give you an example of how you do these calculations. There's nothing, you know, advanced in this. It's astronomy 101, but it's bookkeeping that can actually be kind of tedious if you have never done it before. So we'll open, wrong web browser. It's called Parallax Proper Motion Demo. Okay, and so there's one installation dependency that I hope runs smoothly, although that never seems to happen. See, this command here is to install, there's a function called Astro Query that loads it, basically the way to download information from the Sinbad database of stars, so you can look up stars by their name and not have to go to the website, just download the data directly to your script. So if you run that conda install command, you'll get the Astro Query package, but there's like a special thing to get it from the Astro Query panel. Should just be one command and install pretty quickly. Anyone have success with Astro Query yet? Yeah. All right, so this is an example. It's not 47 UMA, it's another fun exoplanet target, 55 Cancri, just as another example. So you can use Astro Query to get things like what we care about: spectral type, the V magnitude, proper motion, PM, RA, right ascension and declination, and the parallax. And so we get all that data in one shot with the Astro Query.
Yes, my concern about this, as I was sitting here thinking, wow, this is great. I've never done that before. But when I am looking at data for a star, I will go to Sinbad sometimes for it. But I find that I don't know where they're pulling this from, because Sinbad is like a giant dump of so many different catalogs and stuff. And I think there's some calling, like probably this comes from Hipparcos or something, I'm guessing, or maybe it's been updated to Gaia now.
We have Gaia DR2, fortunately.
Okay.
Because I was worried about that too, because I've also seen, you know, oh, forget about spectral types in Sinbad, but like my experience is that it will have, if Gaia DR2 has a parallax and proper motion, Sinbad will use it.
Is using that, and then
so
probably Hipparcos after that.
Yeah, it's probably by now it's supplanted everything. Except for the very, very brightest stars.
So you really don't see Gaia as listed as parallax.
So is this database provide all the possible planets for the star we input?
Not planets. So these are just how, what we know about the distance to the star and its motion when we say proper motion, it means just like how that star moves on the sky. So not the planets. But, oh yeah, so you're asking like,
What's the
this star has known planets. You could probably get things about, that's fine. I'll turn this off. You could probably use Simbad to download data on the planet candidates. No?
Well, you can use, it's in, I'm building a database that will have all this, but you can get it from the Nexi Exoplanet database or there's another database which I can't remember off the top of my head that is accessible via AstroQuery. That's what I'm trying to say.
Okay.
It's called something.
So that means this database tells us for this star with this distance how the thing should move.
Yeah. Yeah. And I should also add, I don't think we made this clear in the beginning today, but we're using 47 UMA as our science target in the simulation, but we're not using the known radial velocity planets that have been discovered many years ago as our planets. So we're inserting purely fictitious planets.
Okay.
And we'll make that clear again when we release the official data. But
this is a 47 UMA-like system that, for the purpose of the data challenge.
Oh, sorry, are you guys giving us RV data?
We are.
Fake RV
Fake
data?
RV data.
Everything is
Don't use
simulated.
real RV data.
Yeah.
Everything is simulated.
Sorry,
Okay.
we should have said that in the beginning.
I might miss that.
That's a good point, yeah.
So this will import all the star parameters because we are using 47 UMA as a star, but then the whole planetary system is fake. So fake, but similar to what we might see, and not that crazy different from what we think is there.
A fake star too.
Yeah, and part of the motivation for saying it's like 47 UMA is because the instrument simulation that generated all those speckles, that's actually simulating the observatory at that sky coordinate pointing and the control system with that flux. So it is the most realistic way to represent the data, even though we want to make our own fake planet system with that. Good, so the next cell you can see we got downloaded our proper motion. So for people who deal with nearby stars, these are pretty high numbers. That's the star that's moving. So you're gonna get a lot of motion even over a few months. And another thing, coordinates. We'll use the coordinates also. So this is a separate step where we download the RA and deck of 55 Cancri. And 47 UMA also, by the way, has a relatively high proper motion, like most nearby stars tend to have. It's also at a short separation. So in the next cell, we're saying we actually want to use, we need to use calendar dates here. So our observations that we provide have specific absolute times in those epochs, and those matter because the parallax offset is going to depend on the calendar date of our observation because of its dependence on the position we are with respect to the sun. And so we make an array of times that go out 1 year out from this first observation date, which I said was April 1st, 2020, using the AstroPy time package. And then we set second observation epoch that is 90 days later. So there are two important times here. The first is the April 1st date, and then AstroPy time, you can just add in units of days, one to another time to get the exact date. So now we need to apply the proper motion from the catalog that we've downloaded to the target star, which is reference. So because the coordinates that we downloaded are epoch 2000 coordinates, the actual position in RA and DEC on the sky in 2020 is not the same. So we have to apply the proper motion to update those RA and DEC values for the first observation epoch. So we're adding the difference in time times the proper motion to the RA and DEC coordinates.
Is it also applying the parallax effect?
Not yet.
Okay.
Yeah. That's... Okay, so now is the part where we do the parallax offset. So because of the fact that the parallax motion is really due to the solar system it's the geometry of the solar system that determines the parallax effect. So we're actually going to use ecliptic coordinates, not equatorial coordinates, to compute the parallax. The only reason we do it that way is because it's a much simpler equation to implement when we do this in ecliptic coordinates. That's because it's on the same plane that Earth is orbiting around the sun. So we convert the, so first we need to know what the ecliptic coordinates of the sun are at each time. And AstroPy does that. It will look up the position of the sun in geocentric coordinates. So we download that, or whether it's computed with some library. Then we convert the equatorial coordinates of the star that were updated for April 2020. Convert those into geocentric ecliptic coordinates. And once we're in those coordinates, we have the sun's apparent position and the star's apparent position in ecliptic coordinates. Then we can apply this textbook formula for the parallax wobble of that star. So I'm not going to spend time going through it, but you can probably find it in a lot of textbooks, but I like this one, Spherical Astronomy. It's kind of a classic. And so we've done this for a whole range of dates. Remember, we did this for a whole year. We set a range of times in increments of 1 day. So we've just filled out an array of parallax offsets in ecliptic coordinates, and we can plot them now. And if it comes out right, you should see an ellipse, some kind of ellipse. So that is the wobble of the star over 1 year. Do the parallax.
And if you wanted it to be high precision, what would you have to do?
Yeah, so that's a good point. This is an approximation, right? The formula that we're using to get the parallax here does not incorporate the fact that Earth's orbit is eccentric.
The Earth, we're not at the sun. I mean, we're not at the very center of the solar system, I guess. The sun.
Yeah, because we really orbit the barycenter of the solar system, not the sun. There are little things that matter at the 1% level that we're ignoring here. It's good. The reason I say this is good enough is because the offsets that we're dealing with, you're only going to be able to measure astrometry to a few milliarc seconds precision in the first place. And so at the 1% level, you're not really going to notice any improvement. But there's Gaia people looking at this calculation will be cringing because of all these approximations. And also, WFIRST is not on the Earth. So we're at L2. We're at a Lagrange point beyond the moon. If that's like another 1% effect, it's not, So thousands of, yeah, million kilometers.
Isn't there like an equation just like this that somebody else has already worked out for doing that correction from L2?
Yeah,
Yeah.
I'm working on the side. Remember Johannes from the Institute was at our March event?
Yes.
So he has a great astrometry library. I'm working with him to make that.
Okay.
But it's a little side project. It's now, so we have the parallax wobble, but it's an ecliptic coordinate. It's not really helpful for orienting our image because we want to get this back into equatorial frame. So the next step is just converting it back to, sorry, actually all we're doing here is converting the offsets, not the absolute coordinates, into equatorial coordinates. So we wind up with this thing called PM, parallax delta RA. That's the offset that includes the proper motion and the parallax for all of the dates that we have. And if we just plot the parallax, you can see that when we're in equatorial offsets, we get a tilted ellipse. That's because we've changed our coordinate frame. And so the ellipse is no longer perpendicular with respect to the solar system's plane. We're plotting here where that offset is at each time. We've set our 2020, April 2020, then the next time that was 90 days later, different offset. Finally, we add the proper motion, or we just plot the one that we added the proper motion to the parallax, and we get our funny wobble that includes that. So these are the offsets that matter, right? This includes the two effects that we computed, and at the bottom, I'm just pointing out what that vector is. If I drew a line between these 2 points, it's a certain number of milliarc seconds in each direction.
This is 365 points because we've sampled once per day, right? It would be kind of interesting to see this plot with those 365 points plotted as points, not as a line, because that would help, I think, convey how quickly the star is moving at any point in time. To, for example, if possible, choose an epoch where it's moving as fast as possible so that within 2 subsequent observations, you as quickly as possible move between the planets and background stuff. Does that make sense what I just said?
Yeah, I agree. If I remember, I think I can do that. Just do dots. Oh, there's too many dots. Or maybe did it not do it?
I think it did.
It did. It looks, yeah, it looks.
So I think if I change the time step,
yeah, like every
10 days.
10 days or something instead of.
Yeah, let's see what happens. No, it's somehow connected. Oh, that's better.
Yeah.
Okay. So that does tell you.
Yeah, so you can see the
sense.
part where it's really moving fast between 10-day observations versus where it's almost kind of not stationary, but not moving too much.
Yeah, I should say that the scheduling of when you point WFIRST at a star depends really on, we have to be at a certain angle from the sun. So that already like heavily constrains.
Yeah, you may not have the freedom to make that kind of choice, but ideally, at least you'd like to have that information.
So that's the motion of the star relative to an infinitely distant background between those 2 times. The thing you have to remember is that if you see, because we're staying in the frame of the star in the center of our image, the background star goes the opposite way, right? So you actually reverse those signs to predict how a background star moves relative to your target star. It's a little counterintuitive, but that's, if you think about it enough, it will make sense to do it that way.
So if a exoplanet moves different than this one, you say that this is exoplanet, different than this Aryan deck.
Yeah, that's one way of looking at it. And another way is that if you see a source that moves this way, there's a very good chance it's a background star. And how you actually exclude that with a certain confidence that's more nuanced, because there's error analysis you would want to do, based on your uncertainty and your measurements of the astrometry.
So how many pixels, like if 100 milliarc seconds is how many pixels on the detector?
Each pixel is about 20 milliarc seconds, so it's something like 5 pixels. So that's all I wanted to show for.
So for a star which has a less proper motion, then how do you differentiate? Because it's they move less than 1 pixel, like 20 milliarc second.
Oh, you mean if you wind up with a vector that's really too small? That's a good question. In our situation, you won't have that, because our epochs are far enough apart that you're going to have plenty of motion.
It happens sometimes, like to confirm a companion candidate from the ground. In some case, 1 year isn't enough. You wait for several years, to see more than a pixel shift. Yes, it can happen, but like in the case of the WFIRST, we aim for really close stars. Usually they have hyper motion, so
those are easy.
But sometimes you can be unlucky. There has been claims of a planetary candidate which had all the looks of a bound companion, and in the end was not. If you this kind of work more either spectroscopy or the common proper motion analysis, but with more precision. Because in this case, it was I think, in this case, I think it was the star. It was a star, but it was moving. It was mimicking common proportion motion because it also had. So that's
really unlucky.
Yeah, very lucky.
Yeah, and I should say, one of the design limitations of CGI is we don't have that many built wavelength bandpasses, so we can't necessarily rely on spectroscopic discrimination. Well, that would be really great, right? If you saw a background star, just get a spectrum. That way we'll know if it's a planet. But in this data set, from the one we're giving you for the data count, there's only one wavelength bandpass. There's not enough spectral data to tell what that is without astrometry.
Next time we could do colors.
Yeah.
You need a new simulation for that.
Simulations.
Should we go right into the PSF subtraction and
Yeah.
subtraction
So
stuff?
I'll take over.
It's a little bit worked here.
Basically, I got to the color accordingly, and then and extracted the stack pattern accordingly.
Yeah, we could do that. It wouldn't be a terrible approximation. And we could actually use the engineering filters as bandpasses.
Yeah.
Different wavelengths.
Was the original IFS plan like for WFIRST, like kind of low resolution spectrum, I guess? Kind of like that of Sphere G-Pi.
That's right. Yeah. Well, especially for CGI, because we're kind of photon starved. We're dealing with really, really faint planets. So you can't do too high of a spectral resolution. Yeah. And so we talked to a group of atmosphere modelers who told us, okay, spectral resolution 50 is the minimum interesting that you can do to get some methane features. And so that's what we designed to.
Oh, okay.
Yes. And that's what we're still designing to.
There's not a dual band filter, right? It's a broadband. Or
what do you mean dual?
Like if you have like two H-band filters, one on say a methane line, one on another to subtract.
Good question. Not right now.
Because it seems like it could be cheaper, like, and still sort of do some of that.
What the atmosphere modelers tell us is that just detecting methane is not going to be so interesting. And that's what you get with those spectral differences. They really want to measure the shape of the absorption, or else you don't get interesting atmosphere inference. And so they really push to get the continuum, the shape of the absorption, and not just do on-off. Because we won't be surprised that there's methane in these gas giants. The solar system has a methane absorption, but the shape of it apparently is what gives us the most.
Okay, so we have only 20 minutes left in this room, or a bit more, maybe. So
she told us till we can get out of here at 2:40.
Yeah, I told her already. 2:40 is good. Yeah. So you have many packages. Well, many no. You have a few packages that are available online to help you do a little bit more. I mean, to go a bit further in extracting astrometry and photometry from high contrast imaging. So one of them is this one that developed in Liège. Well, historically developed in Liège, the group that Malavika is at right now, by Carlos Gomez and collaborators. And so this is the Vortex imaging processing package. So it's called Vortex because it was originally developed for the Vortex coronagraph. And then you have one that's called BiClip. That's mainly developed by Jason Wang, who's now in Caltech. And that's also, they are both linked on the Data Challenge webpage. I'm just showing this one because there's a pretty nice tutorial on how to go pretty far in assessing the photometry and the astrometry, even performing MCMC and getting error bars and so on. So the notebook that I put together with Tiffany Mescat is very, very similar to the tutorial notebook you have here. I would say one of the problems with this package is that it's not necessarily the last version that is easy to install. So in my case, I have one that is running on Python 2.7 and working. I haven't yet got the Python 3 version working. But the aim of this, it's more like a demo in this case. You know, I don't expect everyone to be able to run the whole thing today. One thing that you can play, a nice thing that you can play with is that there is also a binder link somewhere here. I think it's in the oil notebook. Yeah, if you click on binder here, you know that's gonna load the whole Python environment that you need somewhere on the cloud, and it at least allows you to try, you know, and compute each cell of the notebook. So I'm gonna leave that charging while I go back to the demo here. So
I'm not using PyClip, but PyClip is very similar. I don't know if there is such an advanced notebook though. Maybe there is. On the other hand, PyClip is very well maintained, but it was also, this one was developed very closely using example data from VLT, NACO, and Sphere. PyClip was developed very closely with GPy data, so they have their preferred instruments, even though you're supposed to be able to use whatever instruments you want. But then you have to do your own notebook, right? Anyway, the whole point is to show you that there are things available to do pretty advanced recovery of faint companion point sources. So I'm just going to run it. It doesn't take too much time. So if and then so I'm just to show you that I'm running version 0.9.7. I don't know how. This is from March or something. And I'm running Python 2.7, but I intend to investigate how to run it with Python 3 because this is kind of it's possible that the example notebook that they give doesn't run with the latest version. That's what I'm saying. I don't know if you have more information than me on that.
Where is
okay. So the one person in the room that knows VIP very well is Blake. He's been using it extensively during his PhD, but he's also stuck in an older version.
Yeah, and I remember on my old desktop, I had a newer version, and it clashed with boatutils, so I had to change the code a little bit. So I think that could be what some of you are.
I mean, I think the way,
yeah, because I think boatutils changed one of the variables.
Yeah, I mean that's the problem with Python packages. I mean, it's great, it's free, it's all there, it's dynamic, it's changing, but it's changing so much that you look back, you come back, and it doesn't work anymore. You know, like and that happens
also,
with the JWST pipeline, with every kind of thing.
VIP and Radval are using two different versions of this corner thing.
That's right.
So VIP is 1.0 and Radval requires 2.0. So each time you install it, it uninstalls.
No, so the way forward is you need an environment for each.
Yeah.
Because once you have, I mean, I have an environment for VIP and I'm not touching it. Otherwise, I wouldn't be able to show you anything today.
Yeah,
you know,
so
and I have one for
that later.
I have one for the JWST pipeline March. I have one for the, you know, because if you don't do that, it's hard. Anyway, okay, so I loaded basically VIP and a whole bunch of packages. So it's using also, you can do some post-processing with principal component analysis. And it has all kinds of functions implemented to do all kinds of post-processing on ADI data, ground-based. You can do a reference library, you can do different things basically. But we're going to use like the generic wall subtraction and then try to recover the photometry from that. So it's a little bit like from Neil left it, where you left it from, you know, like having these two rolls subtracted and you get this pretty high signal to noise detection. You know, how do you assess the position and the flux of this source? Okay, so you see that I'm opening this file here, and I'm checking the shape. You know, so at the time this was the, I think, the second hackathon. But anyway, you have 45 by 45 and 2 planes, and yeah. So here I basically plot the unocculted PSF, and I assume this is my PSF. You know, if the companion I'm trying to characterize is at 6 lambda over d, I could take the PSF that is at 6 lambda over d in the library. You know, or I could model even better, you know. But in this case, we assume that, let's say we are far away, so it's just like the unocculted PSF. So in fact, it's basically taking a small image, a small aperture around that unocculted PSF, it's modeling it and showing the residuals, basically. So we know like the PSF characteristics, you know, about 2.5 pixels. That's pretty precise. Too many digits here. And then we're going to look at, we're going to compute, oops. So the mean full width half max, okay, and then we normalize. This is the normalized PSF, and we write this file out, okay. And then this is actually the PCA, you know, using this function of detection. This is a detection, automatic detection. So VIP has an automatic detection. If you have a point source, you can set those thresholds. So in this case, you have a SNR of at least 3 sigma clipping, I guess, of 3 here with the background. And in this case, it worked, you know, we detect it here. So that's the same source as Neil was showing before. And so we know roughly its position, right? 28, 15. So, but just to give you an example, if I rerun this with a different threshold, it still works. I don't know, I'm just gonna put like a complete different, it's actually, well, I don't know, but you may have to play a little bit with those to basically get this automatic detection working. But in this case, you don't need the automatic detection. You know, I could have put my mouse, you know, but it could be useful, you know, if you have more than one, and you would, but.
And it also depends a bit on the modes you pick as well. There's like Laplacian of Gaussian, like a few others, and some of them work better than others and kind of detecting it from the noise.
Sorry, what is it using to detect things?
I think it's sigma clipping, right? I mean,
well, this one, it does like a Laplacian and then a Gaussian filter, I think, and then it detects blobs, but there's like a few other methods you can pick.
Yeah, so let's say for the data challenge, the relevance of this function is limited, but it exists, okay. And then, okay, what am I? Okay, so now what we're gonna do is basically inject, import this module to be able to inject fake companions. Because the whole strategy here is that since we know there is something here and we want to characterize that, we're gonna inject a negative fake companion on top of it in the raw data. And then we're going to run the same pairwise subtraction and PCA to try to cancel out the signal. And so that's why this is superior than just doing an aperture photometry here. If you do an aperture photometry here, you have negative signal here and here, right? Whereas if you actually inject a negative model of your companion on top of it, you're going to try to cancel out the whole thing, right? So that's kind of what this package can do. You can also inject positive fake companion on the other side because it's more or less the same noise and just try to match the flux. That's another way. Okay. So here I'm basically saying find where I specified. Okay. Okay, so it's here. It's the next step actually. The next step, I manually put 2815 here because that was where the source was. Okay. So it's doing. Yeah, so it's putting some the fake companion here. and it's doing different steps. You see, it's injecting different fluxes to try to see which one is it is. Oh. Okay.
Your metrics period and then parentheses.
Metrics period.
Yeah, there should be something after metrics. No. Metrics something.
Okay, I have but I don't think it's too bad here. I can still go to the next one. Trying to remember because I am running it live. Okay, so this is so then it's going to use MCMC to throw in a whole bunch of companions, not just in varying the flux, but also varying the position to minimize basically the residuals. So it's basically performing astrometry and photometry at the same time. So in the end, you know, you get well, the thing at the right flux that cancels out the best. And so there is a lot of messages here, but don't worry about that. It's running, and then you get this kind of plots here. Okay. This is probably because some of the and then it's gonna do the corner plots where it's gonna fit for basically position and flux.
Sorry, what are the squiggly plots? Can't see.
So this is flux, this is theta.
Oh, it's just showing you how it's varying the parameters?
Yeah. Okay. So basically you see that they are pretty consistent, you know, it's not they're not filling the whole thing. And in the end, what you get is, so in the end you get the flux, you know, and you get error bars on those flux basically with all the injection that, all the parameter space that you explored with the MCMC. In this case, I get, you know, well, of course, this is not calibrated, you know, then you need to do what Neil explained to go back to what it means in terms of photons and so on. You know? But at least you get the idea of how to get basically a precise position, X and Y, and photometry. So yeah, so if I go back to my binder thing. I don't know where I opened it. Yeah, so basically you get the idea. So this version of this is what I did to get it to work. So it's really not much, but it's basically creating an environment that is Python 2.7, and then it's forcing the installation of this version of VIP. I can send that to the. I don't guarantee it works, but that's what I did in March, and it worked. I think it's better to get it to work on 3.5 or 3.
I realize on this I have 9.8.
You have 9.8,
yeah. So
you just have almost the same. Yeah, okay.
But I think there's a difference because the metrics or the photo they took off, so it's like another kind of move things around each version. So.
Yeah, so that's basically it for this part. I mean, it's just more like, but we can, you know, I'm gonna try to get it to work with the Python 3, and maybe you can then use the same environment installation that I do. So you have this working.
Did you share the installation?
Yeah, I just shared it on Slack.
Oh, I see. Thank you.
So,
So for my case, I downloaded the VIP kit from GitHub, and then I went to that folder and I imported the VIP_HCI.
Yes.
And it worked.
It worked. The whole thing worked. Okay. All right. So that's good to know. And it worked in Python 3.
Yeah.
Okay. So it means they may have fixed, because that was not the case a few weeks ago when I tried. They may have fixed the.
So what do you do? Like
you can clone the GitHub repository in this case. Yeah. So if that works, I mean, do that better. Yeah.
So what did you do?
So if you don't, let's see.
It's giving me a bunch of errors.
In Git, so that's what you need to do basically. Okay.
Okay.
So I just send you the web page. I mean, in principle, that's probably the best way to do, because it should, you know, if you clone a Git repository and maintain it, in principle, the person that works on VIP is making sure it works and uploading and pushing the latest changes. But in some case, you may want to have on the side something that works for you in case they, you know, if they screw up.
It could help, it could break it.
No, up to you. So one way is to have an environment that is stable on your machine. One way is to have always the latest. You know, I think both are maybe important. Have someone online? Oh yeah, we have some.
Yeah. Just keep on that.
I'm not the. No,
Are you the host?
I'm not the host. She's the
that's
host.
it.
I'm just gonna.
Host
Oh, this is done by them.
I want to make some money here.
I hope you can listen, right? You can shout like, can you mute the mic?
Yeah.
That's a good.
Oh, that's fine.
We can't do it from this computer, but I just wanted to turn the volume down.
Do you have a question?
Oh, they muted them. Yeah, it's muted. They're
Oh, it's muted. Okay.
Muted, so they can't hear.
Okay. So anyway, we're gonna have to change rooms soon. So maybe. So okay. So unfortunately, we have to leave this space at, you know, well before 3. The good news is that we're gonna have dinner. No,
Okay, now hurry.
We're not too far actually. Dinner is at 4. We're in the far north, you know. No, so we're supposed to have coffee at the Flatiron in something like 10-15 minutes. So it's a different building. We can all go together. So what I suggest is that people that want to use the restroom now go, and we just meet here in the lobby in 5 minutes and move to Flatiron with Comfort Anne. We have two things we can do during this hour we have right now. One is to keep trying to get things to work, and second is to have Neil has put up a table to help you eventually build some teams if you want to. So like different competencies in different columns, you know, like orbital fitting or spectrometry, I don't know, Python, MCMC,
What you know how to do.
PSF subtraction, and if you feel like you want to do the data challenge on your own, it's okay too. But if you feel like you want to team up with somebody, maybe you can use this.
Yeah, so in the Slack channel, I just put a link
Okay, cool.
to Google Doc.
Some people feel like they would like to be a part of a team or work with other people. So.
It's almost everybody.
Yeah. There's so much.
I think that makes sense. Yeah.
So what type of folks have been signing up for the data challenges? Are there some heavy hitters? Like people we might know that, or?
Not really.
It's
I mean,
mostly people like us who are kind of curious.
It's a good question because you don't have to team up only with the people that are in the room. You can team up with whoever you want, and not everyone was able to come here. You know? I mean, we're just hoping to have the most teams possible or the most participants possible. You know, and also we're hoping to have the most people attempt most of the data challenge questions. You know, because that's going to be more, we're going to learn more. At some point, yeah, most of the people that sign up are probably on the Slack channel on the general.
You made a
that says everyone.
channel.
Oh, the channel.
Okay,
But
right.
some of them haven't signed up to the data challenge. They signed up. Yeah, we had a small hiccup because
Or wait, I don't.
on my schedule I forgot to take floor.
Oh, okay.
I showed it earlier today.
Okay.
Oh, yeah.
No, but I forgot.
Okay.
So I went straight to the 11th
Okay.
floor.
So teaming up.
Why didn't it show up right away?
Sometimes you have to look for them.
So yeah, we can wait.
This is the other library assignment.
Yeah, I'm using, can't get the.
That works.
You gonna do work? You gonna?
No, but I just want to finish this conversation.
I mean, at some point, I'm going to contact people, you know, the wide, as many people as that either sign up to the challenge or participate to our events or express some interest. I'm going to contact more or less everybody to say, like, if you're looking for teammates, go to the Slack channel, you know. But it's okay also to say no. I have my preferred teammates at home, or you know, I just want to do it hand in hand with one person. That's it, you know. Or it's okay. So just an information. We're not gonna ask to write like a paper, but you can do it for you if you want to publish a paper. You can do it. But what we're going to ask, probably, we're going to set up some forms so people submit their results in the same, with the same units and things like that.
We're gonna put together a super cool presentation like what's his face did for the RV challenge. He just did a very nice infographic, set of infographic.
Who did?
The FOSS, the EF, what,
the FOSS.
SSE.
You
should look at, yeah, you should look at what he did for the RV
Okay.
challenge. It was really nice.
Okay.
It's very similar, comparing how well people did. So, yeah.
It'd be great if you find a link to it. Can you put it in the?
Oh, I can do that. Yes,
we're happy to get suggestions.
I just like the way he did it visually. It was very easy to ingest everybody's results.
So also something we already said, but maybe was not that clear, is that so we're going to release on Sunday only the HLC data, not the Starshade data. And on November 20th, so a month later, we're going to release the Starshade data, but you only have one month left, right? So you eventually have more answers in those images, but you know, and in any way we're going to ask. You can go back, you know, but in any case we're going to ask to provide the orbital solution you get with only 2 epochs.
Oh, no, you mask. It's a radio mask.
Xavier, yeah, okay.
So So just to make sure that message got through to everybody, because I'm not sure if everyone was paying attention. We're going to do the data challenge questions will basically come in 3 parts. First 2 epochs only, so fast follow-up, and then all the HLC epochs, so 4 of those total epochs for the chronograph, and then finally the last 2 epochs with the star shade data. And the star shade data will not be given out until November 20th.
So it's a little bit like one is like the tech demo phase, one is like the, you know, CGI is going well and there is a bit of science time, so we were able to do more than the tech demo. And the last one is like, well, fireworks, we also have a star shade.
Yeah.
And it's the end of the mission. And, you know. But I mean, we want to show all the politicians that, you know, can do great stuff that you can only do with this.
Should we go through this and
Yes.
just go around the room and get everybody on here who wants to speak?
So people can edit it, right? Okay.
Yeah, so this link, if you look in the Slack channel, you'll see a link to the spreadsheet. It's pretty simple. There are 3 topics of expertise. One of them I grouped together: astrometry, radial velocity, orbit fitting. Second topic expertise is high contrast image processing or PSF subtraction. And the third is just general experience with using MCMC to analyze data. Importantly, are you looking for teammates? You know, you're allowed to work alone if you really want to, but we want to help people who are still looking for teammates. And we also thought it'd be good if people just wrote down what their favorite languages are, since that could help people have. If we find 2 people who are MATLAB experts, then maybe it makes sense for them to work together.
Angel speaks why.
I mean,
Why? Sorry, I thought that was the answer.
Oh, yeah, so
I mean, you can always do
Why programmer.
I mean, you can do the PSF, the astrometry and photometry in Python, and then give an Excel sheet to someone doing astrometry. You know, it's not, you don't have to do everything in the same.
Yeah. Yeah, and I left one final column just to put any notes or comments or clarifications you want to add.
The person who's entering on the second line right now, her name again? I feel like this is the person who called in earlier too.
Oh yeah.
Oh yeah.
Do you know?
Yeah. So he originally was supposed to come. He's from India.
Oh, right.
And but in the end didn't have the travel money to come away.
That's right. Great.
It should just take 5 minutes as long as everyone knows that link, right?
If you want your picture, professor picture of the equations in the background,
yeah.
that's the moment.
Oh, yes, I'll be here now.
It's better than cheese. Slightly better. And it's
Because I'm following the steps that you sent out, but now that I'm in the environment, it doesn't know that Jupyter Notebook is
You have to
in.
install Jupyter.
Yeah, do you know how what the
Yeah, you can do comments.
Jupyter Labs will do it.
So condense of lab like
Do that.
this is like
Yeah, I know it's like when you're trial and error finding every event.
everything. I think I've installed like 10 versions of
Everything,
yeah.
I think actually I tried the example of the
web page.
Python 2.
Yeah, the binder has some examples.
I've installed like 5 to 10 versions of VIP in different places.
3 delivered stuff looking for the
Because I did install, it works for me, and if I click one, it's like, but then every time I that, nothing. So then,
It didn't work.
and then I did something else, like I have installed with it.
Yeah, I think I've gotten that before
Didn't work
too.
either. So I'm just
No, they'll delay it to your last chat.
This is my last resort for the steps that you
Probably
did.
just a few functions.
I've got 2.7.15.
Oh, wow.
I'm up to date on 2.7.
It's not a competition in the same way that like lots of other things are. I mean, I want to find something.
Okay, that works. I imported it if I just do an environment in Python 2.
Oh, so maybe that's what we need to do is go back to Python 2. Yeah,
I guess
Python 2.
the timeline for doing this is okay, because Python 2 doesn't go away until January, or like, it doesn't stop until.
Well, you can always still install
You
it.
can still
It
use
just
it,
won't
but
be
it just,
improved.
yeah.
I guess it's like a thing.
Okay, this will use.
But yeah, we should walk through how to make separate environment. I don't even remember. That.
Oh, okay, so which
I compiled all these code.
For making, a separate Python 2 environment.
Yes, pretty
Do it
good.
like you did.
Well, I don't think they can that's
Like
actually
make an environment?
You want some
Yeah,
more
we should.
No, I think there's just like, okay, there's, to some extent, you kind of have to make like an earnest effort of it.
So why don't you take over the
Yeah, so she is important.
Well, actually, if you pull up the.
Oh, that
it's in
corner
there. Like, you can have
flashing
like the.
with red belt. One's a newer one, one's
It's
a
the
older
steps.
one.
So if you go to the New York.
Well, I'm able to use both.
I just actually ran like
Yeah, that works, and I think
in the New York.
I made like an ignore it.
So the first two lines of that
But maybe
conduct
you
create
can,
and source activate.
Okay.
Yeah.
So you follow those exact commands?
Those exact commands and it will be.
No, so it's a good.
So hopefully other I think
VIP, yes, but not the.
I think they're
The red belt
going
did work. Yeah, I actually cannot use. Probably should try it out.
Oh, but the first line, that STSI, like they have to.
What does that mean? What does that mean?
What happened when you tried installing the
To like obtain some connections or something, I don't know. So I just
Just
deleted
pop
it.
it off?
Yeah.
I'm not sure why would be there's an error that pops up.
Oh,
so. What I mean.
You'll have corner. Oh, and then environment error. Side. Might be something else giving you an issue though. Sci-fi cluster error. What if you
Do it anywhere.
Oh,
Those commands.
in Windows like the super user?
Well, someone did like, I think they uninstall it first and then do that and then.
No, it's like, it'll stay installed in your current Python, whatever, in Anaconda. But now that you're making
Did
an
that like
environment,
do root?
you have to install it in the environment. So it doesn't matter if you have the.
Oh, just your user. Oh.
Not like you have to have everything in Python is like something
No. It's a thing that you activate and deactivate. So you can source use it as source activate. That's where you activate the Python 2. And then within the terminal, whenever you're done, you
Try
just
without
use
the
source
underscore.
deactivate. And it'll shut off Python 2 and then it'll use the default Python 3.
Do you want to do something? I see, so.
I wonder if I know. So you control when. Yes.
First see if VIP
But
works.
the good thing though is that it'll show if you that you're using. Like it'll show what environment.
I'm not sure. So the problem is, alright, I typed it in. Let me try reinstalling that
Oh, because Python equals rho.
Maybe we should have.
Your estimate? Or maybe another
Just
thing,
to help you.
same, I think you, like I did, I had to install, computer lab.
Oh, I see.
So that's the extra
All
stuff
the
that I
other.
had to do.
What was the resolution to the whole Radwell and VIP meeting? Different corners?
Kind of working on right now, is
Okay.
setting up a separate environment.
We're trying to first get a recipe for VIP.
So you.
But I think we'll probably just have different environments, use each one.
For Radwell and for.
I think it was.
Radville, I'm optimistic we can get working in Python 3, but we're relying on Python 2 for the VIP.
So I guess we only
It
really
seems
need.
that so I was able to get VIP to install with Python.
Messed around with it a little bit and then just sort of see.
Yeah,
But could you run?
but I couldn't import it.
Let me try, let me know.
Cause that's the thing, it's like, it didn't freak out when I installed it, but when I tried to import it, it was like.
Yeah, like, I just be like, okay, I'll let somebody out, oh, it doesn't work out.
Actually, I think we only need to do one environment, because we can then have Radville installed in like your default, yeah. just have one for VIP. You try not to read.
I'm a little lost in all of that. I think I need an explanation kind of from the ground up of what we're actually doing here, because if I have Radval and VIP, like during this tutorial,
the problem with doing
sure I'm not using them
by
both
yourself
at
on
the
a
same
paper
time.
might
If you have an environment,
Teaming up is kind of a
well, you have to make sure that you turn on the environment in one window and then in the other you did that it's like the default. I guess the thing is like, but you can run them at the same time. It's just making sure that where you're running it from, is it like the correct environment?
Okay, and as long as you're in a separate terminal and have separate notebooks.
Yeah,
That's how it works.
Yeah, that's how. Which is annoying, but at least it's a work. Would you be okay?
Yeah.
Not ideal.
Yeah.
So, Nelly, did you get a message like this? I got
Oh
this.
yeah, it like freaked out,
I just
but
expect that I'm gonna like.
yeah, it worked for me.
Well, I'm gonna like.
I don't know why, it gave me a bunch of
Not
errors
do my real
too,
work. to do this,
so,
because I think this is-
but like it worked,
You
so.
See, that's exactly what I'm
One more.
like when you have a paper like in review
This is wild.
already.
It's awful, yeah.
Better than the days of GCC.
But yeah, it works now. I mean, we don't have to deal with it.
My computer's faster than yours.
I know, this is an old junkie loner. Yeah, you got it.
Yeah, that,
This has only like 8 gigabytes of RAM.
And I don't think it's ever
So if you can find the data,
I'm gonna like sit here and do exactly what you do now, because I'm on the same
I'll be-
page with you.
Okay, good. So you see that?
I have done all the commands, except for my computer is now done running that one, and we're waiting patiently.
Okay.
So I was able to import VIP in Python.
What did you just, pip install it and it worked?
Pip installed it in a separate environment
Oh.
from the radio, from the one
Wow.
that has Radvel.
From the one that has Radvel?
Because the issue is between the two of them.
Yeah,
yeah,
So-
the data is actually, I don't know.
I can actually import both. It just tells me you can't use the other right.
Oh, I had to install
That's normal, I
separate.
ignore that, but I have both.
So we're not going to use JavaScript.
It might be because you're in Python.
Not for
Why
the
did you get
examples, I
errors?
mean, yeah.
No, but we're not the only ones. They got
Well, I guess
errors,
we
the
should
same
all
errors.
move to Python.
There has to be
I'm
some
going right now.
dependency.
I'm
that's-
really doing good. Leona's on a Windows machine, right? Yes.
I'm not your bunch.
So many variables.
So maybe it's a Mac
Mac
thing?
problem,
Yeah.
because we're all having
Yeah.
Oh
this
my
issue, and
God.
you guys are not.
Are there any other Linux people?
Only
who-
time in the.
Have you gotten it to work?
So wait,
Not
so
the
does
problem.
this mean that
VIP.
people with Windows
Okay,
are
but
okay
are
with
you having
it,
like
but
a
not with
open
WorkPy?
Mostly
tills,
Unix
like
as
sort
well.
of?
Like-
Linux.
Yes.
Can I see your error?
Well, but the problem is again, still that VIP and Radvel can't be in the same environment.
Because I have mine
Yeah.
sort of working.
Not great.
Separately. Yeah, no, it's really.
Which maybe they
Uh,
figure out how to use Python.
Do you still have to
Okay.
use that extra
Well, I mean, maybe we
know-
don't use VIP then,
Yeah.
or what about?
Oh, and you're
I got
using Windows
to work
too.
Out of the box.
Yeah. That
So what?
I've like I wouldn't have briefly before, so I was like, oh, I'll just.
I just using the regular install instructions that it seems to play well with everything else in the environment, but VIP.
Okay, so I put.
Did you have VIP?
Oh, just not.
No.
Just not VIP for the micro thing.
Oh, okay. And you're using Windows as well, I guess?
Okay.
Or at least I ran some of the
Well, I think Tanya got it working on
I installed
Windows.
from Git,
I didn't know.
because that's I think how it wants you
Yeah.
to.
because someone said.
And then it comes with like some
so I just
tests
download the
and
link. and-
data.
Oh.
Okay.
Oh, okay. Oh, yeah, VIP, HCI, yeah.
Mentioned.
Oh, what are you doing now?
So one more command that's
Yeah.
the same process is you need to install the
I never
Jupyter
found this way.
subsystem to run. So it's Jupyter Lab.
Oh, Conda.
No. I can't just got it running and then
I like use it.
Was that the only one else, the only other one you needed?
Yeah.
Okay.
Feel careful that I'm like somehow undoing all my prior accomplishments from the day.
Oh, no,
You
you're
guys
safe.
say I'm not, okay.
Yeah.
Yeah.
Also,
Okay.
I can't run, well, in the,
Wait, go down.
in Julian's notebook, there's a file that's not there.
Oh, well, you're probably have to change.
That's the error actually they're getting on the Mac as well.
Oh, so when.
Did you try it?
What is it called now?
And you're in
It's
Python
there.
3, right?
It's a different name?
The name and the structure has changed because remember how you in June we were like people didn't like the confusion between time and role.
Yes.
So we switched to simpler. There's one file for each time.
Oh, this is when you install?
And so they have different names now.
Okay.
So you just have to change how it's loading.
So then,
Okay.
so is this file?
You could try. I don't know if it'll work,
I just have to
or
shoot one.
Python.
Yeah.
Okay. Okay.
Or I think this might be related to this, utils like update, where your computer's low on battery actually.
But the source that it comes with has all
Before you
of
do
the
that,
like.
you have to choose your directory where the notebook.
Yeah, so
You can also navigate.
You can navigate,
Yeah.
but if you have like a, I usually like to.
Actually, you might want to ask Tanya, because she was like doing it on Windows. She's using Windows
I think the
also.
problem for me is
I usually like to narrow it down because
That's smart. I mean, that's a better way.
Oh,
and this should be the
One that's not working.
No, this is 3 to 6.
oh, so they're
And I
different
have-
versions.
Yeah, I don't know how that's.
Oh,
Because
okay.
I double extra today too, but extra part.
I just tried.
So if you try importing in this, it's fine, right?
Oh, no, I don't know.
Okay, so that's what I wanted. Okay, so you.
Yeah, so then it's Jupyter Notebook.
Yeah, that, I mean, that works.
Now we have to change these maps.
Yeah, I had to change that. Okay.
It's not important maybe?
Data channel attack. No, but that's a different notebook. Why it's
So
not-
the idea is that.
And why demo VIP.
Yeah,
I
me
can
too.
run one. Let me go back.
Yeah.
I just
I have to scroll.
Oh, it works, okay.
So.
Okay, wait, now this is wiring now. It's no longer here.
Wait, error, wait. So try running Jupyter again.
I
It's like-
tried that.
Oh,
in
you
morning.
did?
Yes,
That's right. So you have to
Probably
make sure that the
computer
match
is 3.6.
like there's only 3 dimensions.
So even if you try like totally closing Jupyter in the terminal and then brand new open.
I think it's just because the Python is different, but I know.
Because it might also be an environment issue, because that seems like it if it's not finding it.
Well, you have it. Yes, but then it doesn't work. So if I do.
Yeah, if you try it in a terminal where it
Yeah,
does.
this is the terminal.
Okay.
I'm not expert
Okay, well,
on
this
both
one-
sides, whereas
It's yeah.
Okay.
It doesn't work.
For the.
And that's because of the.
I got the. It's in 7, and I was just wondering, is it here? I don't have it. Well, some people have.
Oh.
It's naming numbers. So it's apparently about,
So what, like,
is the VHLC.
I haven't tried that.
Yeah, that's good.
Oh, there's a line that takes in a cube and it's like VIP, so I don't know how we change that. Too big.
Oh yeah, like
because I have 2.7. So okay, I'm gonna try.
It's okay. It's sometimes worth.
Yeah, I think I have two different. So okay.
I think, yeah, can you send me the files? Then we can see.
no module name.
Yay!
Yeah, it's important for me.
Oh, I think it did. Don't worry. I think I always. Here.
Do you import this one?
Yes, exactly. So
But other things do work fine, like NumPy, all that
I
stuff.
think so. Those are.
Oh yeah, you have to, that's what I was talking about. It's different now, so the name of the file is different. So if you go to data.
Huh. That's interesting. Because it doesn't, the thing is with that error, it thinks it's not even there. It's like not even.
Go to data, you can just.
I don't know. It's Python 3.
You can just choose
That one's
whatever.
3 also.
So this is 362.
I think it seems like an environment issue, but I'm not sure.
Okay, I find it. It's in the data that I took down. Yeah, so we want this size.
Let me Google.
Yeah, so each one of these has 2 rows. So Neil, I'm still struggling to see like what is the difference
Excuse me.
between the old file and this file.
The new file is just a 3-dimensional array. The old one was 4.
Okay,
So was the last one like had both all of the epics and both the roles? Is that that was the issue? And so this is just like one epic, 2 roles.
That's right. So you should directly assign it to one epoch like that.
Okay.
Why would you ever put space in the file name? That is just wrong. That is wrong.
It used to be, but
So now I have to put quotes around every time I, like, how do you even put that in? It won't, the command line will not.
So what? Oh.
Yeah, so.
oh, that's right. Yeah. So
So I can't like do an LS or.
Oh, it's hard.
that
Yeah,
directory.
it's really.
So how do you?
That they changed.
trying another way because I think I'm running into the same one as
You
you,
don't have to go there.
but there's a way around that.
Python.
But yeah. Anyways, there's a line where it takes in a cube, but it's no longer a cube, so I don't know what to do.
Yeah, that's right. So you should
I thought you told sorry.
so Maggie.
Oh, I had a. You had the error with PP subplot?
Yeah.
Yeah.
I just ignored it.
You can make a file path with, it won't care if there are spaces if you do it this way. Because
Oh yeah.
it's a little smarter.
Just set up the Python.
Yeah, yeah. Set up a pi install.
So for me, my path is like this.
Oh, did you fix it without needing the sudo?
I mean, that can be anything, but it shouldn't care if there's a space.
Yeah.
As long as you use that EOS path.
Okay, so it's
I see. How did you get your path to be that? Oh, because that's the directory from which you started the notebook?
That's where I put the, this directory is where I put the files.
Right. Yeah, that's where mine are too, but why is that your path? How did you get that to be your path?
I set it up here, so you can do just another os.path thing with called rel path where you can use.
Right, actually, yeah, I have my path set up like that.
Did you do this also?
Yeah, okay. So that'll work. No, it was just in my command line when I was trying to like ls the directory, it was like not.
Yeah.
Got it.
Oh, it was a change. He did something. I mean, that would be interesting.
Did Okay, I have to wait. Right.
So yeah, in that step that you're about to run, it takes in a cube, but it's no longer a cube, so it gives an error. That first cube. So I don't know what the solution is. I would have to ask.
You have to ask. That's weird because it's like it already reduced it to one image, so why would it not be happy?
The input parameters is a cube, but I don't know if there's another one for a single one. I don't know what the issue is. Maybe change the dimension. Maybe just adding like a 1 to 45, 45. Could be a workaround. I don't know.
It's it ran.
Yours ran?
Are you sure you're not you're not trying to index up here, right? That would be.
Oh, you did something different.
Yeah, so I'm saying once you have the file name right, you shouldn't do any kind of
Oh, I think that's what
index
I did.
up there.
Wait, so.
Did you get it installed?
Yeah, with 2.7.
Oh, okay.
It's still the same.
So I'm trying to.
Do you want to I'm gonna. Oh, okay.
Yeah, this is because
what is it?
he's missing
Yeah, I did not do
something here.
So, but yours I was also not Actually, let me try something.
Okay, I actually have two new of the versions.
Okay.
It's just the
I think that, so I can run it now.
Oh, okay.
So what I did is
that worked fine. This
I
line
still
worked
kept
fine
the
for you, right?
cube Yes, side off. yes. I should change it for better documentation, but like I
Yeah.
kept it. But then before it was calling either EP1 or EP2.
Yeah.
Epic 1 or Epic 2. Obviously one's both. So that's why I was freaking out.
Yeah.
So I just used site all and it ran AstroPi.
So if you're not programming in Python,
So we're okay now.
it worked. Oh, okay. Yeah, of course. So
Maybe I should try
IDL was my IDL was their my
It goes all the way.
IDL was
Till
their
there.
Oh wait.
Metrics.
people before me it's working. Actually before IDL it was IRAF.
I have to change all of them now.
Which is
Like substitute the name of the file
do something the other day.
every time it calls a cube or instead of Epic 1 just site all.
I got it to work.
But there's a better way because if you just call it up here,
I had to use Pyrat.
That's the only one that
I hated the
matters.
fact that I had to use it.
I had to use IRAF for the course in my university.
you know what I'm saying?
Well,
So
this is Pyrat.
Okay, as long as
It's
those.
the Python version of it.
Yeah, I should do that.
IRAF
Where is that? Like, way
You say that over at, in Tucson, they'll beat you up.
No.
Okay, so. Alright. Yeah, I'll put that. LRPSF currently.
Yeah, so I'm learning Python.
Oh, okay, so that's, I mean, you're in the same step as I am. I'm about to just do one thing.
Yeah.
You want to? Yeah, that's right. Just substitute the first 3 lines for what's as for OS, FD, Sci, Epic 1.
It's like when I went
Because the
to
thing is that the
Word.
format of the file Julian was using was
Why learn how to word? I mean, I tried for like an hour. Screw this.
I know.
I just don't know if that's like.
But like the thing is,
Where do you live again?
In Mississippi right now.
Where are you going skiing in Mississippi? LA.
Sorry, I'll leave it there.
I'm like.
Yeah, so you better write it.
Sorry.
Well, you could pick.
Yeah, there's some, it's pretty crappy.
Utils,
It's for kids.
Is it
But
the
then
same
you
version of
yeah,
Photoshop?
that's 6 hours away, and that's real.
That shouldn't have.
I've been all over. Switzerland, I just went Utah.
Are you getting the same area? Are you getting different area?
Your wife's nice, but shame. Skiing.
I get later.
It's still fall.
Well, I'm reinstalling.
We still get down
Oh,
to
I did
I
not.
could.
You want me to
it's
upload
just
the one I
down
made?
to kick- Yeah, well, I,
We almost, yeah, we're almost there with
we
Python
were
3.
at.
Oh, really? So I'm on Python too. I'm using
Okay,
your
okay.
workarounds.
Okay, so
And the greens are not really green, they will be bluish good. I think I equipment was broke.
I think
I was like, oh my god, I'm so sorry.
been looking at the.
Well, she was terrified, poor thing, it was not a great
And up to date,
I
just
really,
changing
if I
some
do install it.
Oh, that's great.
on to the other
And
one.
so once we get that working, we can put
Should I
the
get rid of it
version 2 and the instructions.
Yeah, I'm happy to do it that way.
Right now, I still have.
That file had a different name, right?
This one.
So we may be working?
This co-ads.
Yeah, that's in another new one that.
Huh?
Oh,
I'm looking.
oh, it's in.
Yeah.
You know how to fix
Did you get any sleep?
Oh, uninstall it. Uninstall it. No, I said
Everything was two, wasn't it?
You have to buy three.
Oh, you are
So
lying?
why? Yeah, uninstall one of them.
I didn't know you were one of those people.
Yeah, yeah.
They will automatically. I mean,
I feel like I got an over two. You're behind me.
I mean, you can remove.
I didn't hear one.
You can install one of them.
Comments, my first reason was running them after the ones that I added, so it's like, it has this, and then I get this.
Yeah, he's really like on the same page here.
Did you get these ones?
Well, this guy, but yeah.
Oh, did you?
That doesn't make sense.
Yeah, it's fine.
Oh, okay.
It's normal.
Did you get this from me? Oh, yeah.
Yes.
I think it's decent. I don't know. I haven't seen any other rooms, so.
Apparently the room's lower down.
It seemed fine at 2 a.m. The lights off.
Okay.
So,
We lost the.
I haven't installed
The view is up
it on this one,
but.
but it.
Oh, yeah, we got
Yeah,
our views of the
that
building, I think.
That happens all the time.
Brick.
You and Iceland, sunshine. Oh, we're good. Good.
Okay, so you were on this
You didn't have a good view in Iceland?
No, because I was on my first floor. I saw a parking lot.
That's not right.
No, it's
No
so
parking lot
crazy.
anywhere.
No, the venue in Iceland. Yeah, it was the Harp Convention Center. The view was gorgeous. It's like a glass building, so we got more than enough view, and we were exhausted when we got to the remaining, so.
Okay, so the plot.
Because every once in a while, I would just when I did my
Stupid space in there is the problem.
Yeah.
So it runs.
I
know. That's so weird that it still gives you.
yeah, like even if it becomes like I went out.
Yes, that temple.
I mean, it.
Must get complaints on a daily basis.
Yeah, Apple.
I'm not sure
You've done
what
that
it
already.
but if it.
Michael said that they tried to switch to those kiosks.
Yeah.
Cut out staff. That's
Have you tried
Yes,
to
that worked.
write a forward?
So, that's what you heard.
I understand.
Yeah, that
They didn't test that currently? I don't know.
Where do you see words
No,
The thing is that the forward slash works if you're not using quotes. If you're using quotes, the spaces are
Yeah,
Which is
so
what happens to me.
to me, it's more likely there's a typo or something.
Yeah.
Wait, let's go on track this. I'm desperate right now.
I'm in a content database, all that.
I think a lot of it got explained to me.
I'm a sophomore.
And then what possibly else be wrong, like that
Yeah.
is the directory.
Yeah. So another command
Metrics dot
try is match to os.tab.exist.
Crazy.
Which is check your directory. I mean, that's inside the Python, like the first cell.
How do you do that? There's this here.
Yes, os.tab.exists, right? And in parentheses, click tab. Just run that. True, so that directory exists.
Okay.
Should work.
We got a really new one.
Oh, it must be the part where.
So let's try to do it. Uninstall coming up.
Maybe symmetrics.
And you can just see it. Because otherwise it won't work. That's why my
Which one you are filling now?
I can't.
I thought. Okay, so those are the names. Oh, it's is one of those, is the collaborative?
Yes, oh yeah, I see what it is.
Yeah,
That's what it is. This is the older one, they changed it and added what happened. No, that was another part, but let me see back to what.
So can you check the platform?
Okay. Yay, okay.
It's not showing
Right.
Oh yeah, you ran. Did your entire notebook?
So are you here now?
No, because of that dot.
Very long time.
You know what happened
Yes,
here?
I think it's supposed to be. I think it's supposed to be done something. It's a bunch of like
Yeah, it should be dot contrast curve, but I think there's still a few more variables that aren't.
Is it? Do you know? It's contrast. Maybe because I wasn't sure which one he was like. But it's still there's a bunch.
Yeah, I think it should be contrast curve. I think that's what.
Contour curve. Subplot. But now it's saying PSF.
Yeah, I think there's some. That's what I'm working on.
I'm
because I
trying to
think there's some
install it
things
in a
that are
clean
not the-
environment. No, I'm just trying to reinstall the environment. There's no different issues, but install they'll work out.
Yeah, so that's the thing that I'm wondering about. So here's supposed to be that.
Yeah, so. Yeah, you have a newer one too, like I do, so you have to change both this line to VIP.HCI.metrics for this in our map.
But if you want to do it with Anaconda, then
You can
install it.
It'll still give you an
If you use Anaconda, then it's important to activate the environment before.
At least. Oh yeah, and also here's VIP.
I think.
Yes, that one, but that's not it, because I think you have to take out the H.
Where's that part?
Yeah, but there's also some other variables not defined, so I'm trying to.
Because I don't know, so apparently if you're. Oh yeah.
I'll look it up from you.
Yeah, they source activate in your environment.
Yeah.
I don't think. Yeah. Well, I'm trying to. I just and I tried to run the CMC and it failed.
Different levels.
Oh, is it working now?
I actually.
No, I'm just
Oh, like just. Oh no, it's not that one. He's like,
create an environment.
Yeah, are you getting all the same errors?
yeah, I have the exact same target here and the exact same.
Environment.
So you also have the, oh no, you've got something else. Wait, what do you have something else?
Not.
You need to be like, you will see
It's not defined.
you're in.
I don't have Starflow, I have
Nothing about
PSF
plotting at all.
Do you have another version?
You're
You might have moved.
Is that the, no, that's the right notebook.
The name, but maybe it's older. I'll just down check it out again.
Python 2.7.
Yeah, so, well anyways, it's the same variable that's not defined anyway.
You don't have Python 1.7 or
Yeah.
what?
In the computer.
Oh, this is just an example.
I don't know what's
So what I do, my user notebook is 362, my terminal is 363.
I think there's a typo.
so
There's a
you-
typo.
Need to equal.
Yes.
Maybe I will type it
I don't think we
I did give up.
I'm just saying that if you're working with Conda, I mean, you don't have to work with Conda.
I know a few of these.
But I don't know, I don't want to with anything, but it doesn't work for me.
already said.
Also, one way.
Oh, but what are you trying to?
Okay, so if we.
I just want to
Probably the easiest
make
way
VIP
is
like the.
So just
VIP
do this thing and then it will,
Yeah, I can't.
Conda
Can't
will
run it
install
till
Python
So
2.7.
if we go to this.
It will not affect your other computer because if you're in this
We
environment,
try to search
Here
for.
it's
Conda
like
will be connected.
example,
Install 1.7.
example that and on example network RDM distortion. And
Place thought for.
I mean, if you're
No, I know what you mean. If you conda will not mess up your computer.
Conda is not a reference.
that is
External comment.
I mean, you have to install conda first if you want to do that.
Okay, we have to do after.
I don't know. Plug in conda though.
I don't know.
Oh, you brought
Yes,
this up.
image.
I'm not sure.
You can sort of put whatever, but it won't have an accurate thing. So that's how they got it. It uses to measure the contrast between, and you do get it in CSS during the main stuff. Because that, so what you're doing is you're just doing aperture photometry on the primary star, and when you do aperture photometry on the planet or whatever, you're using that primary to measure how bright the companion is based on the time that you use and stuff like that. So, I'm not sure what the exposure time
Yeah, I'll show you.
are. New Jersey.
There you can put this out. And then do that.
Okay, so if you go VIP and then try searching PP. Oh, did you already do that?
It's just
I'll search for Cyclone. Yeah.
It's bothering.
It is wrong.
PSF path.
Because there's.
I'm pressing here.
Now it starts with
Yes.
But it has
Plotting,
to-
maybe.
I feel like he defined it.
Is that in the VIP package?
Maybe that
What's everything like?
Yes.
Well, that's in
Now we have the same error meal.
Starboat.
Yeah.
And PSF template is just PSF now.
I just said PSF.
And the other
That's a wild
Okay.
guess, but I.
Are you keeping a record of these changes?
You can't, no, but I installed it from
For everybody? Because you were, I saw that you
I
were.
will.
Very.
I can reproduce them.
Or we can just give people a new.
Yeah, but actually, Julian is also making a better version. Back there. So might have better.
And this is the.
Now, this is
I definitely use that.
I actually tried it.
I don't know about this.
Seems like your computer doesn't recognize the conda.
So.
Just
Sure.
Plotting, yeah, maybe it's in plotting, because I see.
I mean, the ones that.
This is the one.
So where, actually, can you go, you said you saw a
Look, you want
file called plotting,
And I mean, it
right?
should still work.
I don't know.
Yeah.
Let me try.
Go to that.
It'll be interesting to see if it actually works.
It's okay to have like Python to have 2 and Python 3.
It corresponds to
2
the
versions, 5.3, 6.6.
of the non-pornographic PSF.
So that is, for me, that's in that file. You open that up.
Like if you, Sandra, if you just
Vectors
run,
given.
if you just like do which tip.
And PP subplot.
Just like no results.
You search for.
Oh, that's if you have the latest version. Force it to.
I think Conda like somehow like reads, like, you know.
Oh, really?
Wait, can you try installing from
Wait, what does
source?
that mean?
Like getting the repository and then doing Python instead of WY install?
Well,
Does
Conda
it actually
actually
make-
makes you define that aren't in that list.
Because do you really need it?
There's nothing
It's just-
defined
I don't
as
think it's
subplots.
consistent enough between.
Oh, yeah.
Yeah, because
So it should be in
set up to like
bar.
This is what
I don't
Starboard
know
is
why.
doing.
Oh, thanks.
Okay, here's Can you maybe help me understand this jargon and what you understand what it is I
Well,
should
you
be
put it down and then
expecting
you go
of
to
this
the
thing that we're inputting? Like, so, okay, so it says corresponds to the aperture photometry.
You do another
Is
one.
that like what is that?
It's like something.
It's not a flux?
Well,
I'm trying to figure out
it's going to be an CSF because that looks like it's a tiny knob.
Yeah.
Okay.
I think
Maybe that
it's gotta be
works.
related to that. I just don't know what units it was.
That would be one.
Because I think if we figure out the, because there's a bunch of things here that are like printed on this thing, right? Like there's a bunch of, so actually if I look aperture, there's this, all this information about the aperture.
Are we
Right,
able
yeah.
to download
Download
like
star photos.
You guys like stuff. Some do.
Back then,
Yeah,
log
so
percent.
Everything
is
What are those?
Everything starts.
Three environment code.
Yes, now we
I
have.
got it all. I know I keep telling you it's happening in different environments. It's all somehow working. Team together or something. Well, she got her working with Python too.
Yeah.